All right. So this is our last session, Bootcamp Prep Session 8. We're not going to really cover any, I mean, we can go over challenges, or I had something else in mind too that we can do after the slides, but the slides are, they're not really coding slides today. They're just talking about Code Platoon in general, and then like stacks and stuff that Code Platoon covers in their curriculum. So if y'all have any questions about Code Platoon, I can answer most of them from a student perspective too, because I was also a student within their cohort, within a cohort. So I got to experience it as a student, but I was a student with experience. So yeah, I was a student that already had experience, but I know the struggles of programming. So, I mean, I was a student before I was teaching anything. So anyway, oh, sorry, we are on the wrong slide. We are on session 8. So Code Platoon, the full-time curriculum, the full-time course, or I should say the full-time program. It's a 14-week immersive full stack program, which you'll be learning Python, Django, JavaScript, React, HTML, and CSS. Most of those terms probably don't resonate right away. Like a lot of people who know code usually know like the language Python, JavaScript, Ruby, Java, something like that. But usually Django and React are another layer deep. Those are frameworks within that language. They're more specific. So these are all terms that you would know by the end of the cohort. If you were attending it, you'll pay a lot of attention to Python, Django, and JavaScript and React throughout the cohort. So, but you'll start off learning just the language and learning how to write in the language before you ever touch any of those, like before you actually like start diving into just Django and React stuff. So you'll go over like basics and programming concepts and problem solve, kind of everything we did in these prep sessions. You'll basically be doing that, like solving challenges at the start. Solving challenges is a way for you to like learn how to problem solve various scenarios with code. It's because you can't solve things the same way every single time. Sometimes like the problem statement changes just slightly and it changes your whole, you have to rethink your whole solution over again. And this is like development across the board. Every time I get somebody that asks me like how to achieve something, they'll go look up a tutorial where the author of that tutorial is explaining how they solve something, and then the person reading it is trying to apply what that author was, you know, their code snippets from that author to their case, but it doesn't always perfectly line up that way. And that's because like, it's exactly that. Like if the problem statement, if the goal kind of changed just a little bit, then your solution might actually change with it too. So the Code Camp is supposed to teach you, you know, first you start with code challenges and you kind of work out your brain's like problem solving steps with code. And then by the time you get halfway, you know, to like the halfway point of the cohort, you start digging into things like HTML, CSS, and databases. You already kind of are familiar with code, at least writing Python and JavaScript. And then you'll start digging into other topics. You'll start branching out a little bit to make Python do things with HTML and CSS, or make JavaScript do things with HTML and CSS. And you'll start making like code interact with other things. And, you know, you progressively get there to the end where you can like build a full web application. And that's kind of like the goal is to, and you have to keep in mind that I'll talk about full stack development and what that even means, or it says full web development stack, but they call it full stack web development. Normally it takes, if you were to go to a college, you would take, like, you would literally take your time in a college setting, right? So you would do like a 4-year program or something, or maybe they have like a 2 or 3 year certificate program where you can do like web development. And in something like that, you would learn like back end and a little bit of front end, maybe, or maybe just web design, which is mostly front end. And I'll talk about these, and if these words aren't lining up with anything in particular for you, I'll talk about what these things kind of mean. But yeah, most of the time you're spending like years doing this, and this is like a much this curriculum is much more compressed down, and it moves pretty quick. So if you do something like if you do the full-time program, like, you have to make sure that you can commit that time. Students are working on code pretty much all day, like almost like a full-time job. So if you're trying to maintain a job while you're doing it, it's going to be exhausting. But if you have the time, if you have 14-week window where you could commit that time to do this, like, it's totally worth doing. Like, you'll get so much practice in. It's going to be mentally exhausting because you're going to work on so many different problems every single day. Like, you're going to work on a different problem every day throughout the week. And then, like, most of the weekends you'll have to give yourself a break. But yeah, it's very intensive. The full-time program is meant to be intensive, and that's kind of why it's called a coding boot camp. It's meant to be intense, but give you the skills to be an entry-level developer, an entry-level full-stack developer at that. Full-stack developers usually make a little bit more than back-end or front-end. It's usually full-stack development is a combination of back-end development and front-end development. So you know how to do both sides, which is why they get paid more. They can do 2 jobs, basically. But it's a lot of material to learn. So this is a list of their upcoming cohorts, if you're not already in it. I think there was somebody in here that might be an Oscar already, but November has already started. November Platoon has already started. Oscar Platoon will be next. And, you know, these are the dates and times. The dates that they run from. And if you have any questions on the part-time, I probably can't answer that one. But I can ask the teacher, the lead teacher, about this, the part-time program. If you have specific questions about part-time program, I'll have to reach out and ask for you and then relay you the message, because I don't know specifics on the part-time stuff yet. I'm still fairly new to Platoon, or working for them at least. So, but it runs evenings and weekends. I think it's a few days out of the week, 3 or 4 days out of the week. I can't tell you which days off the top of my head, but yeah, if you have questions on that, we can talk about that. You can message me and we can talk about that, and I can reach out to the teacher and get some more information. Platoon, how you are normally paying for it. The tuition fees are like a college tuition fees. They're pretty, like, it's expensive, and most people use some kind of scholarship or GI Bill or vet tech. And that's actually how I that's how I ended up applying to vet tech. Applying to Platoon. I found out about vet tech. I didn't even know it existed. I can't remember how I found out it existed. It might have been a social media post that I saw, but I seen it. And then when I went and explored vet tech's website, Platoon was actually listed as one of the service providers. So that's how I found it. And vet tech is pretty neat. It's kind of like the GI Bill, but it's actually separate funding from the GI Bill. So you can get a housing allowance. I think because of COVID right now, they end up paying you half the rate, kind of like if you were using your GI Bill. For those that are familiar with GI Bill, if you don't attend full-time classes, they pay you at like a reduced rate. And vet tech, if you're doing full remote, which it's kind of hard not to do full remote because it's being enforced, COVID's enforcing like Platoon. has to kind of be remote for the time being. But eventually when they're doing the Chicago class, like in session, live in class sessions, for those that attend in person, you would get the full BAH rate, housing allowance rate, that a GI Bill would pay out. So that's pretty neat. I think it was pretty cool. So I attended I did full-time remote, and it was the reduced BAH rate. So and it's for like just for the 3 months or the 14 weeks that you're attending. So you get that rate paid out to you just like the GI Bill. If you don't end up using that, you can use your GI Bill. And then Code Platoon also offers scholarships as well. Probably going to try to get into Papa Platoon. Sorry, I'm just reading the question. As long as you have a solid connection. Yeah. I mean, as long as you have, so the cohorts usually run Zoom sessions. So you do need a stable connection. Like, as long as you have a decent high-speed connection, you'll be able to like participate in the class. And it's basically a Zoom call. It's just like this that we're doing right now, except they try different styles where they do like webinar style, where the instructor just talks and people, the students can prompt questions in a chat, and it has a different format. And then TAs kind of help filter those down and then present those to the instructor. That way there's not too many disruptions, but they're always iterating and trying to find remote is hard. It's like its own problem to solve. It's not like an in session, in live in class session where you can just raise your hand like that. It's kind of like it's actually even harder for like an instructor because you can't see faces all the time. So it's really hard to gauge. Like you can't look at faces and be like, everybody looks confused, right? Like, so it's really hard in that context. But and you almost want more questions because it's kind of like feedback for the instructor most of the time. So remote is like its own problem. But yeah, it's a Zoom session just like this would be, and you can prompt questions in the chat, and then throughout the day, you basically have like lectures in the morning and like soft skills stuff. So you'll work on like how to set up a resume and a LinkedIn and what things you should or shouldn't put in there. And everyone helps you do a lot of soft skill and like team stuff in the morning. And then you learn how to pair program. In the afternoon, you spend more time coding and pair programming. I thought I turned that ringer off actually. Yeah, I get that. I've been an instructor for a few things before. Yep. Yeah, so it's a different problem than in session classes, like live in-person classes, but it still works. I like it. And you can step away as you need. Once lectures are done, you can step away. And then a lot of time they record the videos just in case like you have an emergency. So a lot of times they'll record those videos and try to have them up the same day. That way, if you had to go to the doctor that day and you'd miss class, you can go back and rewatch what you missed and catch right back up. But it is like every day you're spending a good chunk of time like doing all of the developer things. So that's the only way you can get something like a 2-year program compressed down into 14 weeks like that, is like you're spending a full time, like you're spending a full, like at least an 8-hour day just doing material. It's like going to school for an entire day, but you're just focused on one set of particular topics. So yeah. Active Duty has a program called SkillBridge. So I don't know too much about this. I can reach out if any of y'all have questions about this. So I'm pretty much just going to read it right from the slide. I haven't used this. I wasn't active duty when I applied. I was well out of active duty status when I went through this program. So it's an opportunity for service members to gain valuable civilian work experience through specific industry training, apprenticeships. So basically SkillBridge works with Code Platoon, so you guys can go through the program. And So you have to get approval from your command. Obviously, if you're active duty, you probably already know that. Anything you ever want to do, you have to get approval from your command. You have to, you know, route your paperwork up and get it approved, and, you know, make sure that they're going to let you allocate the time that you're going to need to participate, because this is a full-time program. And you can, yeah, so Platoon has an application process. And I mean, again, I was a student. So actually the application process, I mean, I see why they do it. But the application process was, I felt like it was pretty intense for me from a student perspective. When I was applying, it almost drew me away from applying, especially like some of the things that in the part 2 section that they had for it. But from a student perspective, there was a lot of forms to fill out. But military, you're pretty familiar with filling out forms. It's the same information every time. But they need that to, you know, like validate that you were a service member or you're a dependent. They need all that information for the application process. And then the second step is more of like, it's more of a check to make sure that you are committed. They want to make sure that you are committed, that you want to learn this stuff, that you're applying because you are, you know, you're making a statement where you're saying, this seems like something I want to learn. I'm going to commit myself to this program. So that whole like second step of their application process, it seems excessive, but it's not. It's really to like filter out folks who just, maybe they're not that committed yet, I guess. So you'll have to do some code challenges, like the application code challenges, to get through. They're not all, I don't remember any of them being as difficult. Well, I don't want to say as difficult, but I don't remember any of them being like, what was the one, the multi-part challenge that we did in one of our sessions. I don't remember any of them being too like that level of a difficulty, or like recursion level difficulty. So the last question is, yeah, I'll wait. The last question is in the coding challenges. Oh, like a recursion one. All right, so you'll receive a full scholarship. You don't have to pay out of pocket. So SkillBridge covers it. They'll pay your way if you're active duty. So that's your option if you're active duty. It's probably better to use a program like this if you're active duty, so you don't tap it, like, you know, don't tap into your GI Bill too soon. Because you can use GI Bill. GI Bill usually lets you can usually use a GI Bill while you're active duty, but you're going to use your funds. Why would you do that if active duty, if you can get approval from your command, you can just not even touch that GI Bill money and use another program for like a full ride, basically. So yeah, weigh your options for sure, depending on what your status is. And then there are a limited number of slots per cohort. So it actually used to, I can't tell you what that number is because it was a smaller number when I went through. They limited the class size to a bit smaller. And this current November Platoon cohort is actually maybe 1.5 times bigger than previous cohorts. So it's grown a bit, but they've gotten a little bit more help now. So I still think they're going to limit the slots. So get in as soon as you can get time. Just, you know, if you can make time, they do have a limited number of slots. So if you don't get in soon enough, if you don't try to like schedule that in sometime, you might have to get pushed to a later platoon. So it's always good to check though. You can always email from Code Platoon's website. You can use their contact form and then just ask them like if they're full, or what's the cohort what cohort and the future upcoming cohorts are not full yet, or something like that. Might be worth checking because they all have date ranges if you want to attend them. And so person of contact, if you have questions about like SkillBridge, Alicia, she's awesome. You can contact her if you have any questions on, she helped me with vet tech stuff, and she deals with a lot of the veterans, a lot of these. So if you have questions, reach out. If anyone can help you with vet, GI Bill, vet tech, scholarship stuff, she's probably going to know the answer. So totally reach out to her. She is in the Slack channel for those of you that are in the Slack channel, and otherwise just contact her by email. So coming back to what you learn in Platoon. So you've probably, depending on how long you've been around code, you hear folks talk about the back end and the front end, a server, or sometimes you might hear client side. So what does that actually mean? The front end is usually, the front end code is usually what you, the user, are presented with if you visit any website. Like if you go to Platoon's website, the presentation of the website that you see, all of the colors and all of the, basically all of the styles that are painted out in front of you in that document, that's all client side. That's like what you received from the back end. And you've received a lot. There's a lot of things packed in there that in that request that happened. So when you said coplatoon.com and hit enter, a request is sent out from your machine to their server, and it says, hey, can you give me this page? And it says, yes, I have that page. Here it is. And they send you back what is called a response. You'll learn more about that stuff later. But when your browser receives this response, you basically get packed up, this like packaged up HTML, CSS, and a lot of times JavaScript is in there too. React is usually not in there. But when you're working as a front end developer, you do work with React, but I'll mention that in a minute. But so usually you get this package of HTML, CSS, and JavaScript sent out, and your browser knows how to like display that code. Browsers know how to display HTML and CSS and run JavaScript. So that's what you receive. Now, when I started, I loved the backend. Like I loved databases and like server stuff, basically, like thinking up the logic and how that works and how it's going to respond and what it's going to give back. All of this stuff really interests me, and like how to set up my own database tables. And I'm not a design artistic. I wouldn't describe myself as an artistic person, right? Usually like people are separated into like left or right brain. They're either good with drawing and design things, or they're good with logical problem solving, math, stuff like that. So that's me. I'm the back end side most of the time. I do know the full stack and I know how to style things. I just don't like to. I just like to style my back end code. That's the only thing I like to style. But anyways, you'll find out if you like one or the other as you work with them, because the way you write HTML and CSS is much different than how you would write Python or JavaScript. But you'll end up finding out which one of these you like more than the other, or maybe you'll like both of them equally. Maybe they will both just fascinate you. Sorry, there's questions. All the questions are different now. Which is the easiest to start with, front or back, then migrate to full stack and both? So the cohort, the program, the Platoon program for full stack web development, they're gonna throw you right into both, basically. Like you're getting thrown in the deep end, but you're gonna have support the whole time you're there. So I would not, if this wasn't a curriculum, if you were going solo by yourself to do it yourself, someone just asked me this the other day, actually. They're like, what would you recommend learning first? What would be the preferred path that I should take? Somebody just asked me this yesterday. and I said, I would not recommend, if you're going solo at it, I would not recommend just tackling full stack development. That is so much stuff to tackle at once on your own. Going alone at it, it's overwhelming. It's just an overwhelming amount of stuff. But when you have lines of support to help you through it, it's better. And that's Platoon is basically going to be there the whole time. They're going to give you instructions on what to concentrate on for the day, what challenges to concentrate on for the day, what not to worry about for now, just because programming has so much depth. Front end and back end have so much depth, and they're going to give you guidance the whole way. So it's much easier to go through full stack if you have guidance the whole time. But to tackle it on your own, it is an overwhelming amount. So again, I picked back end because I tried it out a little bit and I liked it, because I tried front end out first, and I didn't know that I didn't like it until I tried the back end. So first, it might actually be easier to get started with front end, if I'm being honest. So because HTML and CSS might actually be the most straightforward way to write. I would call it code, but technically it's called markup, because it's a markup language. So it's kind of like code, but it doesn't really execute like code. You'll find out what that means later too, because there's some depth to the meanings there, like markup language versus programming language. There's some depth there, but they write differently. So HTML and CSS are a more forward way to write code. What you see is what you get, pretty much. But JavaScript, it's like interpretational, right? Like you write something and there can be calculations and all kinds of like calls to calls can happen. So what you see is not always what you get. You have to interpret the things that you're gonna get. And that's kind of like the difference between those two. So once you learn these two, it's getting started with either JavaScript or Python. It's not going to matter. At the end of the day, just pick one and learn it. That's what I would tell you, is pick one and learn it. But the curriculum, the Code Platoon program, the full stack program, it's designed to throw you into both of these right away, because as a developer, you're not ever going to just stick to one language. You're going to learn multiple languages. So they just kind of throw you right into multiple languages, so you can experience the struggles of a developer going from multiple languages. So a lot of times when you're new, the first thing that happens is you start to learn Python, and then you start to learn JavaScript, and then you'll start writing your JavaScript as if it's Python. So you'll start writing, like, you try to set a variable in JavaScript, but you write it the Python way. So that's your first struggle, is like you're writing it the wrong way. That's probably the hardest part between jumping between languages, is remembering how to write a function in JavaScript and then switch your thinking to writing a function in Python. But with practice, it will be obvious to you, because it will come with time. But you can start with either one. This code Bootcamp prep we kind of led you with JavaScript the whole time. This is the way that they designed prep, so I'm running it as they designed it. If I was to choose how to run Bootcamp prep, I think I would have chose Python, because it's my favorite language. It reads nicely. So they call Python a more friendly language for new folks to coding. Like, Python is considered like the beginner friendly language, because it reads cleaner. The code reads kind of like words read, almost like when you skim down Python code, it almost, well, depending on whose Python code you're looking at, when you look down Python code, it reads kind of like sentences would almost read, and it makes it kind of easier to follow. But it doesn't mean that you can't do amazing things with Python, even if it's beginner friendly. You can, like, data scientists use those libraries. I mean, use Python and its libraries so they can build really awesome tools for themselves. But JavaScript has a lot more like parentheses that they use in the curly braces, there's a lot more dependence on having those to define your blocks of code. There's just syntax difference that you have to get used to. And it doesn't matter which one you pick to start with, to be honest. But there are differences between the languages that you do have to pick up on. And if you've been writing JavaScript this whole time, then just stick with JavaScript for now. It would be your best bet. Like, just learn a lot of JavaScript and the concepts. All of the concepts will carry over into other languages. So then when you move to another language to learn a second language, all you have to do is remember your concepts that you learn, like what functions do, what variables, like how you set, well, not how you set variables, but like the concept behind why you would set a variable. And you can carry all that stuff over to another language. And then the language will just, you'll type doing those things a different way. But you can rewrite the same programs with a different language. How much self-learning would you recommend before starting a cohort? Yeah, the sooner you can start, like just jumping in, like if you have any resources for ebooks that you can get for free, or like, I know there's like Humble Bundle, if anybody has that. They give away a lot of programming books. So if you can like find some books prior to starting, or you don't even have to, you can check out resources like Code Academy. Places like that will have free resources so you can learn. They'll give you like textual guided snippets and explain what they are. So you can like get a beginner start on before you start a curriculum if you're going to attend it. And yeah, free code camp. I think that's maybe that's what I was thinking too. Free code camp. Actually, yeah, and there is a free Harvard course. You can literally take a Harvard course. I think it might just be on YouTube at this point. It's a computer science Harvard course, and I think they go over Java maybe in that class, but they go over the concepts. We might be Patrick, we might be thinking of two Harvard courses, or maybe we're thinking of the same one. I don't know. But I know the one that I watched that was a free Harvard course on YouTube, and they covered Java in the class, but it didn't really matter. They were covering concepts of programming in there, which are valuable to watch because it applies across the board to most languages. But yeah, if you can get a head start on learning just some things and practicing with code challenges, it's going to be beneficial. It'd probably be a good idea to do that. And then yeah, the cohort on day one of the program, you basically install all the tools that you're going to need. So it's going to be VS Code. Day one, you're going to install Postgres, which is a database engine, but you're not going to use it on day one. You're not going to use it for weeks. You're not going to use it till like week 4 or 5, maybe. So you're going to install the database engine just so it's there. And then you'll start using it, weeks later. You don't have to install anything for HTML and CSS. That's not needed. You don't have to install anything for that. You just have to have a browser to be able to view what you write. You can create HTML and CSS from scratch. So you'll install Python, you'll install Postgres. JavaScript runs in the browser already. Like when you open Chrome, like you can just run JavaScript in the Chrome DevTools console. Like it's already there. But if you want to run your own challenges on your machine outside of a browser, then you're going to end up installing something called Node.js. If y'all want links to this, I can link you to the things that you would end up installing. Because every one of these, like Python, the Python website is going to have instructions depending on what machine you're running it for, like how to install Python on your machine, or like the Postgres installer, so you can get that installed on your machine. But it's probably good actually to hold off, like installing Postgres. It's probably good to just stick to Replit for now, because on day one, there's going to be instruction sets, like a guided set of instruction sets on what commands that you're going to need to type and how to set up VS Code and put the right configurations in there. So you have a code editor that looks exactly like the instructor's code editor, basically. So maybe hold off on installing all these things on your system, because if you do participate in the curriculum, you're going to set up your system. We're going to make assumptions that you followed their guide on setting it up, basically. But if you don't know if you're going to participate, but you still want to explore, then yeah, I can link y'all to like the installer pages for these. And it's Node.js, not just JS, but I can link you to the installer pages for each one of these, so you can like experiment with your own machine. You read that they want you on a Mac. Ideally, most of the students are on a Mac. I don't know if I'm allowed to say this yet, but I know we do have some students that are Windows, and we've just come up with another solution using Amazon has a service called Cloud9, and we don't know if we're going to keep using it yet or not for sure. We're experimenting with it right now, but it's basically a web browser based code editor like VS Code, but it connects you to like Amazon Web Services. And then basically it connects you to an environment that you can actually write code and build entire applications and run it from Amazon. But it does cost money, but it's like fractions of a cent per hour of usage. So running it for something like 90 hours a month is like $1, like $1 or $2. So it's not super expensive. It's very affordable to do, especially if you're just doing it for 3 months and then you can like get rid of it. So we're exploring that as an option, because the Windows setup is setting up all of the development tools on Windows really depends on what version of Windows you're running, and like system resources and what you're running. So it doesn't always perfectly install on Windows is all I'm saying. Actually, it doesn't always perfectly install on Mac depending on what version you're on either. But Mac is a little easier for the instructors to work out the bugs with, because all of them, most of them are running off of Macs. I specifically run off Windows. I develop in Windows. I grew up on Windows, so I know my way around Windows. But I also have set up Linux machines, so I'm actually fairly fluent in a lot of things. I know a lot of commands to get by on all of the systems. So if you're not very familiar with Windows, then you might still be able to do the program, but they might try to encourage you to use like the Cloud9 setup if they go that route. So it's not a hard no if you don't, but definitely I would reach out to like use the contact form and just ask them about it. Or maybe I can link you to, or maybe I can ask and see what their thought is now, because I actually implemented the solution for Cloud9. So maybe I can go ask how they're feeling about it and see if it's a solution that we're going to stick with or not. Because if it is, then it doesn't really matter what system you're on. You can just use Cloud9, and Cloud9 lets you, like, you could be on a tablet. You could code from a tablet with Cloud9 basically, because you're not running it on your own machine. Anyways, that's something we're exploring right now, just so we don't have to have the requirement of a Mac, because MacBooks are expensive. Can you send us a link including Cloud9? Yeah, I can send you a link to Cloud9, but don't sign up for it yet. I don't want you to accidentally sign up and start getting charged for anything. So we had one student that signed up for the wrong thing, and they immediately got pre-charged some money. So they signed up for the completely wrong thing. But yeah, I can link you to show you, so you can see what Cloud9 even is. I can show you like the product demo, and you can see like what that looks like. It kind of looks like a VS Code window in the browser, and you just edit from that. And it just puts you already inside of a Linux environment, basically, is what happens. So I'll link you. I can link you to, let me, I'll have this chat log. So I'll have to go back through this chat log and then, because I'm not going to remember everybody's name and what I'm sending. So I'll just have to go back to this chat log, and then I'll ping each one of you maybe in Slack individually with links. All right. We can emulate Linux and still do the class. On Windows, Windows has something called Windows Subsystem for Linux, and it's not a perfect, it's not really Linux. It's Windows version of Linux, so it's not a true Linux. So yes and no. You can do a lot of things similar up to a point. It takes a lot of configuration, I should say that. If you want to get your Windows machine to run just like Linux, it takes some extra, like, it's not out of the box working. You have to like go through some tutorials and documentation steps to get your system perfectly set up so you can do all of the things. But that's why we're looking at Cloud9, is because it basically lets me automate setting you up in the perfect environment from the same kind of system every time. That way I don't have to worry about what version of Windows you're on, what version of Mac you're on, how old your computer is. Like if it's like a 4 GB RAM Windows, barely running Windows 10 kind of machine. Yeah, there's so many scenarios. So you can develop from Windows. It takes some configuration. But yeah, so if you're working from like a Linux distribution, like Linux Mint or Ubuntu or Fedora, there's like all kinds of different operating systems, or there's Mac OS. If you're working from any of those, almost out of the box, most of the commands will work. There are some Macs, if you've done certain upgrades, it can throw off some of the install steps, but we can work around them most of the time. But Windows is just like a different beast when it comes to that. And I think they're getting better about it. So I don't want to say it's a hard no for the cohort, because I totally can do it. You just won't get as much. The instructors really can't help you as much with Windows related problems. You're almost on your own if they can't help you debug past the first steps, because they don't use Windows machines. So either you have to know Windows fairly well to work around it, or you're going to want to use something like probably Cloud9. If they go with Cloud9, then Cloud9 is going to be like your best bet at that point, if you can't work around the install problems. But you might not have install problems. You might be perfectly fine the whole time. It really depends. There's so many variables that come into different versions of operating systems, and then getting development tools. But anyway, that was enough of a rant for that. Can you send us the links in Cloud9? I have Windows 10. Yep. Just making sure I scroll down on that. All right. So what does this look like? What is the cohort? I keep saying cohort. The curriculum look like? So it's split into 2 sections. You start with JavaScript and Python challenges. So this is a high level overview. It's not a broken down like week by week overview, but I'm going to try to point out what the week to week looks like in this high level. So you start with Python and JavaScript, just regular plain old JavaScript and Python code challenges. And you basically are given like homework assignments each day. So you do a lecture, you break for lunch. Somewhere between lecture and lunch, you might have some other things in there too, like companies come in and talk about their company, or there's workshops on other topics like web security. And I'm kind of bouncing around throughout the weeks here with these, but you'll do lectures. And then after you come back from lunch, usually you'll go into a Zoom call into breakout rooms. So a smaller subset of the class will be in there, like, 5 or 6 people or something. And there will be like a TA assigned to that room with you. So most people will sit quiet and muted the whole time, and they'll work on their code while they're in there. And then if you have questions, either you can go over it as a group with a TA or the instructor, and then or if we're not trying to, if it's just a one-off question from one student that's having a specific problem, a lot of times we'll just jump in a separate call and then help that one person figure it out, like figure out what their problem is so they can get back on track again. And that's how it usually goes. So you'll just do like code challenges for the first few weeks with JavaScript and Python, and just really learn how to like write functions, call functions, pass data around, get results, and solve those challenges. And then, you know, you'll get into topics like OOP or object-oriented Python or object-oriented programming. But you'll start learning how to write your own custom Python classes and what objects are and how to like construct your own implementations inside of Python. And you'll do some equivalent things in JavaScript as well. And then you'll move on to HTML and CSS after that. So you'll get your first view of writing like static HTML and static CSS and like putting together piece by piece, just like a website. It's not running on a server or anything. It just runs off your own machine, but you'll get familiarity with that. And then like using something like Bootstrap, which is a CSS framework, helps you write CSS faster or style your pages faster. But you'll learn how to do it, you know, the long way first, because the long way is like what really teaches you what you need to know. And after you get through HTML and CSS, I'm going off of a memory here. So after you do core code, HTML and CSS, I believe you jump into doing SQL next. So SQL is a language. It's called Structured Query Language is what it stands for. And it's basically like its own language, just like Python and JavaScript, except it's, it's kind of like HTML and CSS. What you write is kind of what you get with it. It's very structured and what you're telling it when you're making statements of about what you want it to run. So SQL, this language is used to perform queries against a database. So if you have a database somewhere, anywhere in the world, it could be on AWS services, like they can be hosting it in the cloud for you. It could be running on your own machine. You can connect to a database and then send it a SQL command, and it will give you back some results. It'll give you back some kind of result set. You'll say, I want you to give me information from a table, and that's what it will do. So you'll learn how to write SQL and interact with your Postgres that's installed on your machine. So you'll learn how to create a table and then set up that table and then put data in that table and then get data out of that table and update that table. So you'll learn all of the operations to perform all of the tasks that you would normally perform against the database. And then after you learn databases, you actually will use, you'll use Python in combination with SQL. So you can have your Python code, you'll have Python code write SQL and have Python talk to that database. And then you'll build like a program out of that. So you'll build some kind of program that uses a database, and from scratch, you're going to build this stuff from scratch. And it's all going to be like outlined, and they'll go over, each day has a lecture that covers like how to do this stuff. So you're guided the whole way, and then you have support the whole way. And once you get through like these main pieces right here, once you get through SQL and building a program simply in Python, you move on to something like a web framework where the pieces that you built in here are already part of this framework. Like the pieces that you experimented and wrote yourself and implemented yourself, you don't have to implement those yourself. Some developer created this framework to handle the most common cases. So you actually get to leverage what somebody else implemented with best practices, and then you get to use their version of what you wrote, and to do the same thing, to query a database and then display a web page. So yeah, you'll go through ORMs and the framework. And once you hit this part of Django, you'll actually swap back over to JavaScript and learn how to use a React framework and a Django framework together. And once you pass that, you'll learn how to do API. You'll learn how to do these same things, but then you'll introduce APIs into it, and what APIs even are, like REST APIs, because that kind of powers today's, a lot of today's technology. Any web app you've ever interacted with that you can access that also has like a mobile version of it, where they have a web and a mobile version at the same time and they look kind of the same, they can pull the same data, it's probably talking to an API. Like Twitter, I can go to the Twitter website, or I can get Twitter on my phone. My phone version of Twitter is just, it's just asking for, it's hitting the Twitter API is what they call it, pulls data in, and the web app does the same thing. And they just display it to the screens differently, but they're pulling the same exact data. But you'll learn how to do that, APIs. And yeah, you'll start getting into the OO object-oriented programming version of JavaScript later. So you'll get introduced to it with Python first, but JavaScript you kind of hold off because it's not really JavaScript. JavaScript kind of sticks more towards function-based programming than it does trying to write classes. And you'll see once you get far enough into any language, it will become a little bit more clear. But JavaScript likes, the community around JavaScript tends to stick towards functions. They're a lot faster to make, less expensive, as in performance-wise to make. And some developers just don't like making classes. They just don't like the, there's a lot of reason. There's a lot of depth and reasoning behind it I don't want to go into, but this isn't a course for that. Anyways, that's pretty much what it looks like. By the time you get to React, Django, and like building this API, so you would build a web API on the backend side, and then you're going to make a React app to talk to the backend. So you're going to make the front end side, the backend side separately, and then you're going to make the front end talk to that backend that you created. Basically as if you're like creating your own version of what Twitter has created, right? Like they've created a front end, it talks to an API backend. You're going to basically create that. It's not going to be Twitter though. It's going to be an assignment project, like a class assignment level project. So it's not going to be, you're not going to have the same actually, you will have some of the same considerations as Twitter probably had to make, but it's all intentionally there so you can, struggle through the problems and learn. Will we start with the basics of JavaScript, Python, and end with OOP? Yeah. So, well, you won't end with OOP. You'll actually start with it earlier with Python, but you probably won't see it earlier in JavaScript. So you'll see OO JavaScript when you start getting into React, because React has two ways to write React, and one of them is like function-based components and the other one is class-based components, and that's where you really start to see a lot of classes in React. That's kind of like the only time I see classes in JavaScript ever written was when I was working with React. But Python is heavily object-oriented. So it's JavaScript can do or imitate object-oriented programming. Python is object-oriented. So that means everything in Python is based off of a class. So you see classes all the time. Like classes are definitely a thing that you use a lot in Python. JavaScript, not so much. And that's why they kind of like counter each other. So Python, it's introduced sooner because classes in Python are like, it's a main part of the language. JavaScript is not really a main part of language. You can get by without ever using a class in JavaScript. You can get by with functions the whole times. Hopefully that made sense. But so all of these things combined basically add up to what is full stack development. And these are actually, these things right here are actually separate jobs themselves. So you'll actually see front end jobs, which you would write JavaScript, HTML, CSS, and use maybe React framework within the scope of this job. And then this job, you would be more database driven. You would work with backend. You would be working with the code that works with the server most of the time. So you would deal with requests and responses all the time. So these are two separate jobs, and full stack development is a combination of knowing both of these things, combining this knowledge so that you can effectively do the front and the back end at the same time. Like you have the capabilities to do that stuff. And full stack developers actually make a fair bit more in most cases. They make, there's a lot of full stack developers making 100K, like base salary, 100K. Well, if you're lucky enough to find a company that's trying to hire out for that. It really depends on the company and where it's located. So I'm not saying that's like every place everywhere, because everywhere is different, but backend developers are probably around, entry level could be like 50 to 65 is probably a good entry level average maybe. And then front end's probably about the same. Like back end, front end, entry level is about the same, and it really depends on the company. And the bigger the company, the bigger problems they have. So you're solving bigger problems usually, and their salary adjusts based off of that. So if you're working for Microsoft or Tesla, right? If you're working for one of them, they have big problems they have to solve. Usually their salary matches that. Usually you're making like over 100K. Some of them make 130. So it's a ridiculous amount of money, but you're solving some ridiculous problems. But you're going to approach it almost the same way you approach all your code challenges, right? Like you're going to step by step, you're going to run it, it's going to fail, and you're going to like keep testing it and keep trying different things until you can understand your solution. And that's pretty much what development cycle is. And it's iterative, and you get better with time. And the better you get, you can move up the chain and get into higher positions and get paid more. I think every senior developer position I've ever seen is always over 100K. So if you can make it up the chain to senior developer, you can be making, you'll be set. You'll be set for a while. Has anyone from Code Platoon got hired by Microsoft or Google? I don't know about Microsoft, but I know I have talked with I think I talked with a TA that was working at Google or working for Google. And it was really in passing. But yeah, there's so many other companies too. It's not just Microsoft and Google. Code Platoon, they have a lot of companies that they're, I'd say, partnered with. A lot of companies that like to come in and give talks to the curriculum, like during the curriculum. I mean, they'll come in and give a presentation about, like, JP Morgan can come in and give an awesome presentation on what they do there, like that. You can ask them any questions when they come in. They'll just come in and say, does anybody have questions about what we do? And they'll tell you what some of their problems are, like things like banking transaction problems that they have and things that they have to solve. And they're huge. Like JP Morgan is huge. So they'll tell you about some of their problems. You just have to like raise the question, or and they're always looking for new talent too. And that's kind of the reason they give their presentation. They're just like drawing interest and seeing if you're interested enough to apply to something like that. But it's not just them. There's so many companies that Code Platoon, they're really good about it. Code Platoon's really good about it. They'll reach out to all these companies and see like we have students, they're passionate students learning how to code. Are these companies interested in coming in, giving a presentation about themselves and maybe working with us to get veterans hired? Is pretty much the goal. So they're the instructors and the executives, the CEO, Code Platoon, he's always trying to get It's important to him. He's always trying to get people hired. They have so many volunteers from companies that even I've gotten to work with some of them. But yeah, I'm trying to tell you without being too specific. I don't want to just drop all these names. I don't know if I'm even allowed to do that, but I've already dropped a few names that I don't even know if I'm allowed to say, but it's, I think I'll be fine. I didn't say anything bad about anybody. So, yeah, it's pretty awesome. I like what they're doing. I like what their mission is and their goal and serving the veterans and stuff. So that's why I'm still here and I'm helping everybody. I noticed AWS in the curriculum too. What role does that play in full stack development? AWS, yeah. So anytime you get into development, at some point, like if you build an app, right, there's always one other side, which is they call it Devops, developer operations. This is like kind of outside the scope of front end and back end. It starts to get into something else, like infrastructure, or like how are you going to run this code? Like what server is going to run your code and how is it going to run it? And so you start getting into like AWS services is one option. It's only one option, right? It's one, like they have a lot of options in there. It's because there's so many different ways that there's so many different services that you could use to run code these days. So AWS provides you with tools so that you can like get your code into one of their services and then run it in the cloud. So like running off of their server, using their servers to scale your app to like serve a lot of people, right? Because you can't, I mean, you could, let's give you another hypothetical. The first thing that I tried to do, it's not a good idea. Don't do this. Especially if you have no idea what you're doing. I didn't know what I was doing at the time. I had somewhat of an idea. So at my own house, I was like, all right, I don't need to pay for any services, right? I can just host a server. I know how to set up a server. I'll just host this server from my house, which you're not supposed to do. First of all, you're not supposed to do that. You have to have a business grade internet to your house to be allowed to do that. If they find out you're doing that, they'll cancel your service, or they might just send you a strongly worded letter to not do that again. But you're not supposed to run a dedicated server from your house. But I was just experimenting. I was curious if I could even do it. So the first thing I did, I wanted to run my web app, and I wanted to be able to access my own web app from like my mobile phone, right? Like outside of my home network. I wanted to leave my house, go somewhere else, get on the internet and access my app, which takes some configuration to set up. And this whole thing, this configuration to set up is like DevOps. It's like you have to set up the server that runs your app, and like opening ports for firewalls, all of those things, securing the connections that come into your app. There's a lot of things in there. I happen to know some DevOps stuff at this point too, but I didn't when I started. So AWS helps you streamline best practices for hosting your app. Like they give you services that are meant to be used that way, so that you don't have to worry about hackers trying to break into your home network all day, which is what I ended up with. Luckily, I set my installation, all my server stuff up correctly. And so I checked the logs at the end of one day, like 30 minutes of my server being on, I was getting hit by everywhere, like basically bots that scan the internet for open ports. That's what they do all day. They're just scripts that they run really fast, and they just like try to ping everything that's on the internet. Because they can just like guess IP addresses the whole time. So sorry, I'm going way too in depth on this, but I'm just trying to give you an example of like, this is DevOps related things, and you'll pick up on some of it no matter what you do. Like in development, you'll pick up on it, but it is its own topic, and you do get introduced to it. And Platoon takes you through kind of setting up. They have AWS. You actually get AWS. I'm trying to remember the name of it. It's it's a course provided by AWS that Code Platoon gives you access to. So it's like a series of courses that you get to do on the side and learn about how AWS works, how to use some of the services. But you also learn how to host your app on other places like Heroku, if you've heard of that one. Heroku uses AWS in the backend, but they make the setting up process even easier. So you learn how to host your own app, basically. Sorry, that was a long way to get to saying that. That was a long road I just took to get to that point. But anyways, it's DevOps is what they call it, developer operations. And it's really all about like the security of your app and like setting up a server, configuring that server to be your server needs to be set up the right way to run your app, and you know where to put the log files and stuff like that, so you can debug your app if they're like a production app. And when I say production app, I just mean like the live website. Like if you went to Microsoft.com right now, that's their live site. So if they broke something and pushed bad code up, like you'd see their page break, and they, something bad would have happened right there. So somebody messed up. Someone didn't test it before they pushed it. And or maybe somebody broke like something on the server and broke. So there's always logs to check that you can check your debug your app from. Anyways, I think that's the last slide actually. Yeah, so we have plenty of time left to go over pretty much anything. I can, if there's any questions about any of this stuff I covered, this is pretty much highlighting high-level view of what you would go over, what you would learn in the curriculum. And it's a lot of information. It looks so, looking at it this way, it makes it look so refined, like there's not a lot. Every one of these topics has depth to it. Like I could abstract, like I could expand each one of these topics out to a lot of learning points. So there's a lot of depth in each one of these, and you spend each week going over like those things, like 8 hours a day, basically. In the full-time curriculum, 8 hours a day. And the part-time, I imagine to be like half that time. So you'd spend like 3 or 4 hours a day. But the lectures are usually like an hour, and then you spend more time coding than you do somebody talking at you. Because it's more important that you're experimenting with the ideas rather than just getting talked at the whole time. And that's what I'm trying to always do in here too, is like, I want you to see me struggle with code, because no teacher you talk to, they struggle. Like struggling is, get used to it. It's going to happen, right? Like get comfortable with struggling, and it's frustrating at first when you're new, but get used to it. It's like a familiar feeling now. I like when it happens. It makes me even more curious now when it happens. I'm like, why does that happen? Who can I ask that can help explain this better? Or maybe I can go find a Stack Overflow post where somebody just like rants on why this happened so I can understand it. I love those moments. I just had one this past week in JavaScript, and it's the craziest thing to look at, but maybe I'll share it with you sometime when you guys get far enough into your challenges for me to brain dump something crazy, like weirdness in a language on you. Yeah, so we can, I think I already read that. I had 2 thoughts, so we can pick a challenge. If y'all want to go over a challenge, we can. But then I was also thinking, like, maybe we can, I don't know how far REPL it will let us go, but I don't have anything planned, but we could try to build like a game, like a very simple game inside the REPL session with JavaScript. And I was thinking, like, the easiest thing that comes to mind is like a number guessing game, like guess a number between 1 and whatever, and then it takes in inputs, right? We can build like some kind of simple program so you can see what it's like to like try to build a program out that you can run and tweak or something like that. Or we can just stick to the challenges, and y'all can pick a challenge and we can go over another challenge. Because challenges themselves are fairly focused. It's not really a program. when you build like an application or web app or any kind of program, it's not one problem. It's not one challenge in there. It's a series of challenges. Like, how do I get from point A to point B and then point B to point C? It's like you're solving multiple challenges throughout your program because you have a goal in mind, right? So we can do a building of some kind of program. We can like collectively build this thing. We'll try to keep it simple, or yeah, we can go over a code challenge if you prefer. It doesn't matter, either one. I'm open to whatever. I thought maybe it would just maybe something different, maybe fun to do like a program or something, but yeah, if y'all want to go over any kind of that or a code challenge, we can. Just drop it in the chat. If you prefer a class built, we'll wing together some kind of guessing game program, or we can do a challenge. So just let me know. I don't think I missed any questions, did I? I have Windows. Yep, I think I got to all the questions so far. No one has any preference, or maybe I can't. Let me make sure I'm not muted, or I can hear. Okay. You prefer the guessing game? All right. Yeah, I mean, we can do the guessing game. I did share a code snippet a few days ago. Let me go back here. Where did I share that at? Did I scroll past it? I thought I shared it. Maybe I didn't share it. Oh yeah, here we go. Yesterday. So I shared a short snippet that shows kind of how to get the ability to prompt a user for some input, and we're going to need that if we do this. Actually, if you build any kind of console-based program where you need to get input, you're going to need something like that. It's linked in Slack in the Bootcamp prep channel. So let me get this open. We'll do it in this. I'll just do it in this one. So the first thing I need to do is require, so things that we haven't really covered yet, I guess. I'll just explain it for the time being. So we are going to do a guessing game. I've got a number guessing game. We need this. This is called a package, right? Like it's an Npm package is what it's going to be. Npm is a Node package manager, and it basically lets you install other libraries outside of Node. Like Node came with some pre-built things that are already there. It runs JavaScript and it has things that are already pre-built in there, right? So Npm lets us reach out to other packages and let us use someone else's code that like the community is using, basically. So React is actually a package, that thing that we talked about on the slide. React, the framework. Django, the framework, is a package. It runs inside of Python. React runs inside of JavaScript. So we're basically installing additional features that we can use. This one is called Prompt Sync, and I can actually show you like where these things exist on the internet. So if we just type npm prompt sync like this, you'll get this website, npmjs.com. You'll see it. So you're taken to a page that looks like this, and it, you know, this is what like package pages usually look like. So a sync prompt for Node, very simple, no C++ bindings or bash scripts. Works on Linux, Mac OS, and Windows. And so they tell you how to use it in your code, like how to get the package in your code, and then how to do something with it right here. So these are like the first two examples of how to use it. But if you're not using Replit, you're going to have to like explicitly install it yourself if you have Node.js on your computer. And again, if you want to install Node.js on your computer so you can do stuff like this, it's fine. But it's probably easier to just use something like Replit, because they take commands like this out of the way. Actually, that's a package that has an extra option. It looks like history. It comes with a history. It's the same package with an extra feature added to it or something. Anyways, this is what it looks like. And documentation pages tend to look like this, where they try to give you all of the context for what's there, like what's possible. And a lot of this is hard to read as a beginner at first. You have to get used to some of the terminology that you'll see. Instance, you'll just, as you go through here, you'll see they highlight things certain ways. It takes time. Documentation takes practice to learn, and not everybody writes documentation the same way. So you get used to it and you practice with it and debug your way through it. But it tries to give you like what things are for, and then you try to be like, okay, well, I'm going to take whatever idea I have from reading this and go try it out. And then if it fails, then you come back here and be like, all right, I must have misinterpreted what they meant. So that's half of your time debugging is spent doing that, to be honest, is like, oh, I misinterpreted what they meant. And here's like a much bigger example where they have what looks to be a much more complex program starting to happen. So enter your name, enter your password, enter a hidden password. So it looks like they're trying like things that maybe other people have tried before. Like they try to build a console prompter for logging into something maybe. So this is a lot to look at for the beginning. We're not going to worry about that yet. We're going to go with some very basics, like something like this. I just seen a question. Input would come from console, right? Yeah, so Python has one called input, and we can like put our prompt in here, like what we want to say. JavaScript, I was trying to find something that worked just like that because it's more straightforward to do that, because otherwise you have to do like what do they call it? It's like it's standard output, but if you look it up, it looks ridiculous. I was almost not going to even do this because I needed to find a package that made it more straightforward, because if we don't do it this way, watch what happens when we do this. So Node, like if I typed in how to prompt for input Node.js, and look at, I've already clicked through these before just because I was seeing like what's the best, like what's the popular way people are doing this. And this article is fairly old. Always keep, when you're looking things up like this, 2011, that was a while ago. This should be like at least 2019 maybe, if I would consider like actually doing this. It needs to be a fairly recent article. But look what they had to do just so they could prompt for a question, and then you're like, what is this? Like, what are they doing right here? Like this would be a lot for me to try to like go through and explain step by step, like what's a function with another function, and I'm prompting, it's like prompting a question and it accepts a like all of these things, and then like we would have to go run this to see how it would work. This is a lot to take in at once, just to take y'all through like building up a program. I don't want to focus on this. It's a lot to do. So I'm getting this package that has a much easier interface to use, so that we can say, so I can just say prompt, guess a number, right? Like my ultimate goal is to like ask for a number. Actually, we should probably outline that right now. Like, what are the rules? We can invent our own rules. We don't even have to follow the regular rules for the game. Holy moly, my screen is dark. Or my camera is dark. Hold on one second. That's better. I didn't realize how dark my room was getting until I looked at my own camera. I was just starting to fade away. What are the rules for this game? So, I mean, like the normal rules, if we went over them, like, normally someone would be like, guess a number. Someone, when I say someone, we're going to say like the console is the someone, and someone needs to ask, the console needs to ask, prompt me for, maybe at first it's going to welcome me to the game, right? So the console welcomes me to the start of the game, right? That's kind of which is easy. That's just like a console.log, right? I can just literally say welcome to the game. Maybe it could ask what my name is, and then it can say welcome to the game, Chris, or something like that. But that's pretty straightforward. Maybe I'll leave some stuff out on purpose so y'all can tweak the game into your own liking if you want. I'll share this at the end of our session. And so console welcomes me to the start of the game. Then maybe I can have it say, maybe we can have some extra steps in here too. Like console asks me if I won't get into menus yet. I don't want to do game menus yet, but we'll just assume that they ran it and they're going to start the game immediately. So we'll just say asks me to guess my number, right? And then when it asks me to guess my number, now it's my turn, right? So the user, actually, I'm going to change this from asks to prompts me to guess my number, and then user, I'm just planning. This is like me planning out what ideally I want to happen. We're going to map this into code again. So the user is me, but I am representing like anyone who would play this game in the console. So the user, me, I'm going to type in my guess. Hopefully, I'm going to put this here just as a side note. Hopefully I type a number, because it's going to ask me to input something. I can press anything on my keyboard and hit enter. So hopefully I guessed a number, and I'm putting that there intentionally because I know that maybe the user accidentally types a number and hits a character on their way to go hit enter or something, right? Like maybe they made a mistake along the way. So you have to keep that stuff in mind. Not this early on. We don't have to count for edge cases, but I'm going to just throw that there because we're not going to solve it at first, but we can solve it later. Or maybe I'll leave it there for y'all to solve. So I take my guess. Yeah, things like it can't be blank or it wasn't a number. Like you have to make those considerations too. If you start assuming that the user perfectly enters what you wanted, then you're going to be lying to yourself because people on the internet don't always interpret what you want them to put in a field. You have to like tell them or make them, right? Like I won't allow you to enter this until you put it in right, basically. So user as me, I type in my guess, and then when I give the guess back, I expect that the console is going to say well, let me ask this. Do y'all want to build this in the way where the console is not very informative, where it's like, no, that was wrong. Like it's either no, that was wrong, or yes, you got it. So we could build it that way. Or we could be more, we could be like, no, you need to guess higher, or no, you need to guess lower, that kind of way. Like it could be more descriptive about it without giving the answer, but tell you which way to go, like what direction you need to guess in, right?
The second way.
The second way. Yeah, so let's pretend that, hopefully I type in a number. We have to consider both sides, right? We have to consider either I entered the correct answer or I entered an incorrect answer. So maybe I'll like sub this, not like an extra, like a nested list under this 4 right here, because I'm basically branching my path right here, right? Like 2 things have to happen. I need to, like, the console needs to check my guess against what it has, or what it remembers, I should say. Actually, I left a step. As I wrote that line, I left a step out of this. The console has never selected. I never made, like, it's something that you don't really think about. But there is a step in here that I kind of left out. So when we start the program, even though the console is welcoming me to the game and prompting me to guess a number, there is maybe one more thing that at the start of the program that the console should do. Maybe at the start of the program, the console randomly selects what the answer will be. And maybe we can hard code this at first so we can test it. Hard code this at first to test it. So I'll put that there. And when I say hard code it, we're just gonna like set it. We're gonna set the answer knowingly so we can just check our code. And then we can make it so it chooses randomly later, just so we can make sure that our code runs right how we expect. And we can intentionally guess the wrong answer at first, but then later we can make it random, and then we won't know what the answer is, and we will actually have to guess. Because we're the developer, we know what's in the code, right? So the console needs to check my guess against what it remembers or it's stored. And so to do that, or when it does that, I should say, there are 2 sides. They're like, yes, I got it, or no, I need to guess again. So on this one, we might want to say, this one itself kind of has like its own sub branch, right? So if it's no, here, maybe I should nest these a little bit like this. It would look better. Yes, I got it. Then let's just say we're gonna end the game. The game is over. I guessed the right answer. And then this one is no, I need to guess again. But it has like 2 branches here. Like I need to say, guess higher, or it's going to be, I'm kind of breaking these out step by step, or guess lower. These are 2 scenarios that can happen, right? If it's no, I need to tell the user, I need to figure out if they guessed too high or if they guessed too low. And then I need to tell them, hey, you need to guess higher on your next guess. And so this whole process right here, so selects what the answer will be, welcomes me to the start of the game. This is probably out of order, or maybe not, because it's going to run individually for each time we run the program. Welcomes me to the game, immediately asks me to guess a number. I type in my guess when it prompts me, hopefully giving it a number, and it's going to take that number and check it against its number. And then when it does that, it's either going to determine, yes, they are equal, you have guessed the right one, or no, it was not equal, and it needs to figure out if it needs to tell me to guess higher or lower. And after this last step, when it tells me that, like when it tells me, hey, you need to guess higher or lower, it probably should circle back to prompting me for my number. So it needs to, like, step 5 is really like circle back to step 2. Prompt me for that next number. Well, not really step 5, right? It's like step 4. So because 4A actually, whoops, I put C. I didn't nest these the right way. So I did put it right here and end the game or end the program. So I kind of put it in the same line. So if we make it past, if we make it to here, we basically need to like loop. Exactly. And if we get it wrong, we need to tell the user, we have to give the user some kind of output and let them know like what happened. They need, because otherwise like they would guess, they would get no feedback. So you need to be able to always tell the user, hey, you did something wrong. This is what you need to do. That's for console. That's what we're building, is like a console-based program here. So if we do that and we constantly give feedback to the user about what action they were trying to perform, they'll be able to make a better decision the next time. So I think this is probably good to start with. It's a fair bit of steps, but I think we can get through this using only what we learned so far. Maybe we'll see. So randomly selects what, so the first thing we need to do is like when the program starts, when I run this script, the first thing I want to do is like select number, but I did say that I'm going to hard code it at first, which is perfectly fine. So I'm going to say, I'll use const for now. And we'll say, for testing, let's make a decision right now to stick between 1 and 10, because if you go really high, well, if you didn't know the answer, testing between 1 and 10 is easy. Testing between 1 and 100 would take you, every time you try to test your code, it's going to take a while to figure it out what it is. But let's just say between 1, I don't know why my sound is still on, between 1 and 10. And I'm going to set the answer to 7 for the moment, right? And so this program needs to welcome me to the game, and that's fine. If we want to send output to the user, we can always just console.log, right? Like I think I've shown you this one a few times. We can always console.log things out. I can just console.log text out and say, welcome to the Javascript. Sorry, someone's mic was, Neil, that was your mic. I had to mute you. I don't know if you're trying to ask a question or anything, but your mic was doing a feedback loop. Welcome to the JS guessing game. We'll just do that. So if I'm going to stop right here and run it, and we haven't done very much except I just want to see that, these 3 lines will work so far, just so I make sure that Replit is going to actually npm install this for me, because it conveniently does that for you. See, if I go, yeah, see, so it's running the npm install prompt. Well, it's doing prompt and prompt sync. And it's taking a minute. There it goes. All right. So it ran and it worked, and it actually generated some new files. This is I won't go too in depth on this. If you don't know what this, just don't edit this if you don't know too much about what this is, you'll have to go read a little bit about it. But this is how npm decides what packages are part of your program. So it's called package.json. It basically lists like dependencies for your program, and mine should be in here. Dependencies. My program to run requires prompt and prompt sync. So if anybody wants to run my program on their computer without Replit, they would have to npm install these two things for it to work. But that's beyond what we need to worry about right now. But if you're curious about what these files are, they have to do with requirements to run your program, basically. Packages that are required to run. And
so if we did this in VS Code, we would have to put that code snippet in there?
Yeah, you would have to, your computer would have to have Node on it, right? Like you would have to have, to be able to run this in VS Code, you would have to have Node installed on your computer. VS Code would use Node. Because to run this program on your own computer, you can't just, VS Code does have a play button like this. If it's hooked up right, it will work. Like you can push play and it will run it. But behind the scenes, what VS Code is doing for you is like running it, right? It's running the file like that, if that makes sense. Like they give you a convenient button, but it's behind the scenes, it's just running the file for you that you push the play button on. That makes sense. They kind of hid it away, right? Like they hid the need to be able to do this. I can just push the button and it runs the program and keeps me inside this console at the same time. It's two ways to do the same thing.
But we would still have to have that code snippet that you have in the program to do it in VS Code that you have up there in the program.
Yeah. So from your computer, if you were to take this snippet and try to run it on your machine, like if I took this and went to here, let me create, because I have Node on my computer, so I could do this. So if I did index.js and I VS Code, is it going to open? It's not going to open. Oh, I didn't do what I thought I did. I don't know why I typed VS Code. Just thinking it, I guess. So it's opening VS Code up for me in that file. And if I just paste this code in now and save it, if I don't have, let me not do that. I'll just try to run the file. That's probably what you would get, right? Like you get this error and it just looks cryptic. But the very first thing it says is cannot find module prompt sync. And that's because VS Code, remember when I hit play the first time, not VS Code, Replit actually detects that I put this in here and did it for me. So that's just a Replit thing. That's not a Node thing.
Oh, okay, thanks.
Yeah. So, but if you want to run it, you can. The only thing that you have to do is do exactly what Replit did, right? So they did this right here. Let me do that same command. I'm going to intentionally leave off their first, they separate packages with spaces. So npm install, I'm not going to put the first prompt that they put. I'm just going to do the second one and see what happens. So they're installing two packages. So there's a good chance that they did that maybe this prompt sync relies on this one existing first. Maybe it's like some kind of wrapper around it, but let's find out. If this doesn't run again, then I probably need to have both of those. So I'm just showing you how to like debug your way through like package errors at this point. So node index, and we run it. No, it works without it. So it might have installed it itself. Like this install might have just installed that, and maybe I don't know why they put both of them if only one of them was necessary. So anyways, you do that command. So, and then once you do that, once I have the dependencies that are required to run the program, now I can run the program. So now it runs it on my own machine. And you see how it runs and then it stops. It's done. It ran the extent of the program. So it ran this line, and that line. And then it reached no more lines. It said, okay, I'm done. I'm going to exit now. And once it exits, now I have to call it again. I have to call the file to run it again. So I just keep running it each time. But yeah, we can, that's how you can run it locally. If you have, again, you have to, if you can do this in your command prompt or terminal, node space -- version. If it gives you a command, if you don't have it, you'll get this. It'll say node command not found, and that means you don't have it installed. So yeah, that's kind of what it looks like. If you get an output that says a version, then you probably have it. So if I do it here, I am running this is the version of Node that I'm running, 14.15.1. I think the most recent is 15, actually, so V15. So Replit running an older version than my computer's running. So it's good to know. Yep, so let's go to, what was the next step? Welcome to the guessing game. So I need to prompt now. And from this package right here, they said the way that I can use this thing, like I have to define it like this. I mean, they used var, but again, if you go back to session 1 and 2, we talked about var. Var is kind of older. This package has probably been around for a while. I don't even know when they created it. Oh, I guess this specific one has been around for a year, published a year ago. But var, most folks use like const now, like constant, unless there's some reason they chose var, like they needed to reassign. But anyways, this is how you set it. You just set your package. So they have to do this weird thing where it looks like they call it when they import it, or when they require it, and then they call it prompt. And so prompt now becomes this thing that we can call. It kind of looks like we're calling it like a function, and we're passing it a string into it. And whatever that string is probably what, my assumption is, like, it's going to give us a prompt now. But let's see what happens when we do exactly what they did too. So how did they write that? They said, we want to set a variable and set it equal to the call to the prompt. So we're going to do that same thing. So I'm going to use let, not var. I'm going to call this user input, maybe, and do the prompt thing. And the thing I want to say is, guess your number, not your name, your number. And yeah, let's try that. And if you do this and you notice that they put a space here, and if we don't put a space there, we can find out maybe why they did that. And then let's do that. And then I'm going to console.log back out this input, and just to see, let's prefix it with something like entered input, like this. So I'm gonna ask for input, and then hopefully it prompts me. I can put something in, and then I can just spit it back out again. I can just spit out what it was. I say spit out. I could just output to the console exactly what it said to me. So run it, and it looks like it errored. Cannot create property autocomplete on string, guess your number. So did I miss something? Because autocomplete on string, guess your number. So let's see what that is. I can try to find autocomplete. Config prompt. So cool, we got our first error. A completer function that will be called when the user enters tab to allow for autocomplete. Oh, they support autocomplete in a prompt. That's kind of cool. An empty array is returned if there's no matches. That's weird that they didn't. Oh, is it this thing? It's probably that thing. That's weird that they didn't specify that. So normally if it doesn't make sense right here like this, like, okay, I still don't know exactly what I need to do, right? Like overrides the instance autocomplete function. Still not really telling me anything. Okay, they did it a weird way up there. So there's this one, like this example has a lot more to it, right? They actually, on the require line, they said history, and then they did this. I don't even know what that means, but for the moment, let me see if that will, how did they do that actually? They put in the parentheses, they put these braces, basically an object literal right here as an argument to this thing that they did. Oh, I just didn't do it. Okay, so maybe that's the problem, right? Like they had like empty, that was probably the problem. Maybe, let's find out. Yeah, so I just didn't do what they did. So I literally looked at that and did not put it how they had it. So right here, right? So I wasn't paying attention. I just wrote this much of it, forgot that. So that's good. Easy mistake. But now it's prompting me, right? Like I can type in here. So I can type anything I want. So I could just type my name, and then it says my entered input, and it has my name because that's what I entered. So let's run it again. Now if I put 8, okay. Now I'm curious, I'm mostly curious what this data type is. Let me get rid of, I happen to know that in the console, if I just put 8, a number shows up usually, on Replit, a number shows up like that, right? On my own machine, if I was in a node console, 8, like the number becomes a different color for me. So, and then a string is green. What is a string in here? It's also green. So I want to see if I can, oh, it's a console.log message though. I wonder if I could just, maybe it will return the last line for me here. Nope, still doesn't do it. So we can ask what the type is. I can say console.log. I don't remember if I used this before, but it's built into the language. We can ask the type of on a data type, like, wait, is it like this? I don't remember off the top of my head. I'm going to confuse this with Python in a minute. We'll see if that works. I think it's called type of, but JavaScript ask for type. If I do MDN, so, okay, so I don't need to put the parentheses. So if I do a type of and I pass the variable right here, it should tell me if it's a number, a string, a Boolean. And that's pretty much what I want to know, because I want to know what prompt is storing for the data type. Because as I said in the beginning of these sessions, like data type is always important. It's the thing that you always want to keep in mind all of the time, because this one is a number. Because I'm eventually going to compare this data type against the user's data type. That's eventually what's going to happen. And in the beginning, when you're a new user or a new programmer, you don't think about that. You just say, I have a variable and I have a variable. Let me try to compare them. But under the hood, JavaScript is definitely considering what type it is. So we need to know what that thing is. And I'm going to take these parentheses out. That's where I was going. And we're going to say, all right, what if I put in 1, 2, 3? It says it's a string. What if I put in Chris? Still a string. All right. And then if I don't put anything. It's still a string. So it's always a string so far. So that might be a problem, right? I'm going to eventually try to compare those. One's a number type, one's a string type. Might create a problem. So I'm looking ahead to, we can compare them and see what happens just for learning experience, but I'll comment that out. I'm trying to leave comments in some code of what I did. So you'll have references still there. So I get the user input, right? I type in my guess. Hopefully I typed a number, and then we've already gotten to that point because we leveraged that library. Like we didn't have to somehow figure out how to get input, write the code to get input out of a console ourselves. We got to leverage somebody else's library code that already does that. All we have to do is call it like this. So libraries are super useful for that. So guess your number, I prompt them. Number 2. That's the prompt. I can type my guess into that prompt, so I pretty much got that nailed. So I need to check my guess against what it remembers for it, like its answer. And so we can go, okay, if I can do a comparison, right? I can say, basically, is the answer equal to what the user input, right? I can do a condition like this. So if they are equal, then we win, basically. So I can console.log like winning message in here. I'll just leave it as winning message. We'll change it to something else because that's easy, right? Like that's the easiest case, is like they got it on the first try. Like this condition is comparing if they got it right. So the easiest case is they got it right on the first try. They won, we can end. The next case is the else side. If they didn't get it right, the else side means this code runs if they got it wrong. So user got it wrong, right? So now in here, this is where we have our branching, right? Where we said, if you got it wrong, we have to figure out if you need to go higher or lower. So first, we know they're wrong. And then we have the loop inside the else side. Yeah, we could. I'm trying to hold off on the loops so that we have to explicitly run this, but we can add a loop around this so that we can replay the game if we want. But I'm trying to hold off on, I didn't want to add that section in yet. There is a way to write it so we can like play this game as many times as we want over and over again and not have to end the game. Like the program doesn't have to end. We can make the program run forever if we want. But sorry, somebody was saying something in the chat. I was just answering. So we have the winning side, and this is the losing. Let me just put that. This is the losing side, and that's the winning side, or winning case, I guess we could call it. I'll call it winning side. The user got it wrong, so we need to say higher or lower, right? We want to do, they need to guess again, but we want to also give them an indication before we prompt them again. We want to say guess higher or guess lower. So first we need to check. We have to perform our check. So we need to take their answer and say if the user's answer was, and then we have our comparison operators. So instead of like equals, we can do like greater than or less than. So greater than faces to the opening of the greater than symbol faces to the left. So that's the greater than. Less than, the small end, the less than side, the small side aims at the left. So that's how you can, if you ever get those confused, that's less than, that's greater than. the one you pick matters. So if the user's input was bigger than our answer, we want to do something. Otherwise, we want to do something else. So this is if user answer what, well, let me keep this the same. User input was greater than the answer. And the opposite side of that is user input wasn't greater. It means it was, we've already accounted for the equals, so we don't have to check the equals, because this, just to side note this first check checks for equality. It says if they are equal to each other. So this block ran, it either ran or it didn't run. And if it doesn't run, that means this whole block runs. So we already checked for equality. So don't worry about checking for equality here, because we kind of already did it. So if the user input was greater, we want to do something else. The user input was not greater, so it was less than the answer. Well,
would they guess again for both situations?
Yeah. So, and that repetitive, that last prompting line, right? This circling back, this going back around again, it pretty much indicates that we're gonna need a loop to do. We basically want to rerun all of the same things we did prior, like at a certain point. So it usually indicates, hey, maybe I can wrap some kind of loop mechanism around this. But yeah, we'll get to that one. We'll get to that one after this. I just want to get the logic in place so that we can play one time, right? Like we can try to do this one iteration through before we ever hit a loop. So if if greater than, guess again. If less than, guess again. Yeah, both of these cases, if this whole block runs, they have to guess again. But this is just checking whether we want to say guess again and well, we could say guess if they guessed high and they didn't get it right, but they guessed too high, basically. So let me move this comment actually, because maybe that helps it make more sense, because working out this logic needs to make sense. So the user got it wrong by guessing too high. I'm gonna put that. And then here, whoops, trying to be consistent, too low. So in both cases, I can console.log something here that gives them an indication what they need to do on the next time, but we haven't implemented the next time yet. So in both of these cases, I want to say guess again, or like, oops, you guessed too high, try again. That's a decent message. And this same message, maybe it's the same thing, but maybe I put too low, right? So now I could probably run this and maybe try one time. And I intentionally didn't, I told you that this thing was a string, and we are doing there's two types of equal sign. There's this one, equality operators. This one is the strict equality. And this one is, we'll just call it not strict or normal, the normal one, I guess. Strict is what you normally use. Strict has an extra, I covered this one in the previous session, but strict it does one extra check for you. And it's really comparing your types, the value and the types, but the double equal just compares values. It doesn't even care about the types, which is kind of weird, but like, why wouldn't you care about the type? But yeah, let's run this real quick just to make sure that we can play like we can get all of these messages. We can get the right version of all of these messages. So first I'm going to look at my answer. I'm setting it to 7, and then it's going to ask for input. It's going to compare my input to the answer, and it's going to give me a message based off of that. So I know that the answer is 7, but I'm not going to pick 7 because I want to check each side of these conditions. So for I'm telling you what I'm thinking out loud right now, so you can follow why I'm like choosing these things. But I'm going to intentionally not pick 7 because I want to skip this one for now, because I want to not pick 7 so I can check this whole block. But if I pick 5, then I'm expecting to hit this. So I'm going in with the expectations here. So if I pick 5, I'm expecting that I should be welcome to the game. I should get prompted for my number 1 time. And then if I put in 5, I hopefully hit this one. And then we'll try something higher than 7. So we'll try 8 so we can check this condition. And then we'll try 7 so we can check this side of the if statement. So we're trying to check each side of each of this nested if statement and the outer one right here. So I have to play the game 3 individual times really quick just to check the expectations. So it says guess your number. I'm going to try 5 because I know that's less than 7. And it says oops. Oh, I put you guessed too low. Okay, so you guessed too low. So that's just to make the text read better, but oops, you guessed too low. Try again. That's what I wanted. I wanted this line to run. So good so far. What happens if I give it 8? So the answer is 7. I give it 8. It says, oops, you guessed too high. Try again. Wait a minute. See, I was expecting that to not pass that because I use strict equals. My answer is 7. All right, that's interesting. See, I was expecting this to, let me see. I was expecting a false. Oh, I'm not doing equals. Ah, that's why I'm doing this. Oops, sorry. I have them backwards. I'm doing user input greater than 7. Haha. So that's good to know. I wasn't thinking about that. I was thinking about this case, strict equals. If you do that, it's false, obviously. But if I do this, it's also false. But if I take one of these extra equals out, now it's true. Because the triple equals is strictly compares the data types along with the value. The double equals doesn't compare the type of string to number as well. That's good. And this is good to know. And for some reason, my brain immediately thought it was going to do that, but it didn't. It actually just compared. That could be good or bad. It could be a good thing or a bad thing, but right now it works. So I'm not gonna fix it yet, or I'm not gonna try to do anything extra to it just yet, because it works. Okay. Is there a strict greater than? You know what? I actually thought there was. I actually thought there was, and I tried to do it in one of our sessions where I just assumed that because there was a triple equals, that there would be a greater than or equal to, like strict greater than. Yeah, for the very first one, right? Yeah, so it says you can do this, but I'm pretty sure I tried this. This implication wouldn't hold for, okay, yeah, so they have some reasoning for it, I guess, for it to not exist. However, I think a strict greater than or less than would behave consistently. So they're having a discussion about the existence of that. But I mean, we could try it, right? We could try it. We don't even have to like look it up to try it. If you know how to jump into a REPL session like this, you can literally just say like 7 less than equal, like less than with 2 equal signs like this, and it says syntax error. Like that's the wrong syntax. I gave it one more character than it was expecting. Like I could do it either way, greater than or equal to. I just can't do the triple because that's not a thing. I tried to actually do this in a previous session because my brain was like, there's a triple equals for comparison operators. That must mean there's a strict version of all of the operators. And my brain, that was totally an assumption on my part. And I thought I actually put it in a slide, but I didn't. I was like, thank God, because I would have been like completely wrong if I put it, even more wrong if I put it in a slide. Anyways, there's simple mistakes, easy to look up or easy to test in a REPL session if you just can't remember. Like me, I've worked between PHP, Java, Python, Ruby, and JavaScript. So keeping all the operators straight is like, I have to look them up too. It just happens. Like keeping all of the syntaxes that you have worked with in what exists and what doesn't, or some of them have like a slightly differently typed version of it. Anyway, so it works for now, but there's probably a case we aren't covering for that maybe, but we'll find out. We can find out with some more testing of this. So the only one I haven't checked yet is the winning side. So I just need to play one more time and put in a 7. Aha. Wait. Oh yeah, it's a strict equals, right? So a strict equals is not, it's not doing it. It doesn't want to have it. If I turn that to a double equals like this, I just did this, sorry, but I'll do it again. It would pass, but you're always encouraged to use triple equals to match types. But if prompt always returns a string, do y'all remember how to get a string into an integer? Or I said an integer. Do you know how to get a string into a number? Like I want to convert whatever came out of this into a number. That way I can compare a number to a number, and I can leave this as my strict typing. Parse int. Yep. Yeah, so we can try, I can do it on the very next line where I say, all right, I got my input. It has a string in it. Let me reset it now to parse int and pass my, the right side of the equal runs first before the left side. So the way you read this is you read this right side of the equals first as what happens first prior to this assignment side happening. So this user input is referencing line 26. It's referencing the previous value. So the previous value was a string. So this string right here is getting coerced into, like JavaScript is like, hey, I'm going to try to turn you into a number if I can. Try to turn string into number type. So now we can try leaving this triple equals there and running it and putting a 7. And now I get my winning message. So I guessed, so this is, we pretty much have like the skeleton of the logic that we want right now. So it's going to work up to that point. But I actually know a few things here. Like you could keep going, or you could test a few other things. Like because I added this parse int in and it's operating on my input value. What happens if I don't put a number? What if I put a C in here now? Uh-oh, like it didn't even fail. It just kept going. It said, I guessed too low with the letter C. Okay, what if I put more than one letter in here? Same effect. What if I try different letters of the alphabet, or maybe like a symbol? Nope, they all pretty much go default to too low. Console.log a letter. What if the user inputs? Yeah, exactly. That's what you probably asked that right before I did this. So yeah, so what's happening is parse int is trying to convert the letter into a number So what is it though? Like, let's find out what it became. Because I'm curious, like, it didn't fail, but it kept going. Oops, what did I do? Oh, comma. So let me put like a C in there again. Ah, so it became a different data type is what happened. What it became, NaN. NaN is not a number. So now if we wanted to check, we're like, okay, well, if it didn't fail with red errors, right? So it just kept going. So that means user input was this value, NaN. So it's basically as if this happened, right? So obviously that wasn't true. So it ran these blocks now, which means user input was NaN, which means that was a false, so that every time it tries to convert letters into, when you try to parse int on letters, it seems that you're going to get not a number. And so it's going to fail for this every time like numbers come in, and it's going to just give this output, which is kind of consistent, which is good. So if I do, whoops, not user input. If I do NaN greater than 7, I get false. So this answer wouldn't matter. No matter if we pick 1 through 10 or whatever, it's always going to be, this will always end up being false when you compare not a number to a number. It's just false every time. So this is always going to run. So maybe there's a way we can check if it's a number. Like, what if there was some kind of check we did to do, maybe we can add a check for invalid characters, non-numbers, right? So maybe that's a thing we can add. I'm just going to put a to-do right here for now. Well, what's happening? There we go. So we're basically going to ignore that case for the moment, because it's a case where the user is just entering the wrong things, maybe on purpose or because they misinterpreted it. But we have a to-do here, so that maybe we know about it at least, and we can address it at any time. We just left a comment for ourselves to address it. But now the game doesn't run perfectly how I want. Like, I want to be able to say, all right, 7, I won, and maybe at the very last line, right, we have one final console.log that says game over, or no, thanks for playing, right? Something like that. That way we know, can tell the user, they can tell that like it ended basically. So that's a pretty simple game, but it's not like, what if I don't want to end? What if I want to, I got the answer right, but it still ends if I get it wrong, which isn't what I want. It's not perfectly what I want. What if I guess a 5? I guess too low. Thanks for playing. It told me I can try again, but thanks for playing. So yeah, we need something that lets us iterate back to the top again. Like, we don't want to exit this game until they get it right, maybe. Or maybe there's a certain amount of guesses until it's a game over. If user input is a space, enter a valid number. Yeah, so yeah, handling, there's some clever techniques to handling whether something is a number or not, or the thing that you're trying to check for, right? So, all right, so I kind of want to get this loop implemented so we can at least play the game through one time. Like, it will start, every time we get it wrong, it will keep looping. And once we eventually get it right, it will stop, like the game will then stop. And that will feel like one instance of a game played. Like that will, like one playthrough basically. So we need, if they immediately get it, we don't need to loop, but we do have to recheck their answer. We do have to reprompt and recheck this answer against this strict equals. So this does have to be inside the loop as well. So, because we're going to have to keep comparing all of this whole entire condition block has to be in some kind of a loop. But technically this prompting also has to be in the loop. But what I'm going to do is considered a bad practice. I'm going to repeat myself. So initially I'm going to have these two lines, just because I'm trying to keep this as beginner friendly as possible. And because this is possible to do, like I can reuse this prompt again to say, to say guess a number again. I don't only have to do it this one time, but there are principles of coding where it's like, don't repeat yourself, like don't rewrite the same lines of code over and over again, or the same chunks of code. If I want to repeat some kind of action, usually there's a better way to handle it. But I'm going to do that on purpose because I'm trying to keep this fairly simple and straightforward so y'all can tinker with it a little bit. So I am going to want to reprompt for an input again, but I really need to get this loop started somewhere. And I think I'm going to do it. I'm going to leave those there. So when we went over looping mechanisms, like for all the different kinds of for loops, the one thing that they have in common on for loops is that for loops normally start from a number, there's like this style, right, where let I equals, it starts from 0. There's some condition right here that needs to be met, and then there's like an I++ where it increments a certain amount of times. This is this incrementation is only going to happen up to the point of the condition. So I mean, this, I could technically put a true here because that would make it, it's a weird way to, it's really a weird way to write an infinite loop, but I want my program to keep going. But then the question is how do I get out of my loop? Because I don't think I've shown you anything that would let you get out of your loop without a proper condition. So I'm not going to use a for loop because there's another loop that is more ideal for like looping for a lot of times without having to keep account. But maybe you want to keep account for some reason. I don't know. We could still keep account. So there's a while loop. We haven't used this one very much at all, but a while loop, it also takes just a condition. And if this condition, as long as this condition is true, it will keep running the loop. So this statement right here, I'm trying to point out, we need to type something in here where basically that we don't want to end this game until they get it right. So this is technically my condition. Like if their answer is equal to my input, game over. Like the game should be done. Which means I'll probably have to change this code a little bit. So the first thing I can do is move this answer and user input. I don't know if I'm gonna like this, all these comments, leftover comments from if I leave them inside of here, but we're gonna see what happens if I'm leaving my old code still there, but commented out. So now I've moved my condition up in the top. I'm saying if this answer is equal to this user input, which is right here. So this will definitely take care of the very first time because I will have gotten my input right here. And then I need to actually reprompt every time. I know that inside this loop, I'm going to have to reprompt. So I'm going to do that now, but I don't know exactly where in the loop I want to put it yet. So user input, prompt, guess your number. And this is me like repeating that line again, basically. So actually I'm reassigning input. So now I know that every time this thing loops, it's going to prompt for guess your number. But I also know that it's going to already have asked me that. Like it's, and I also need to do this line again too, right? So I basically have to repeat a few lines of code, which is probably a bad practice. There's probably a better way for me to like do these things. Maybe if we have time, we'll refactor that a little bit. I don't know if we'll have enough time, but it's fine as long as we can get this to work before we end today. So we have our while loop. It's going to keep looping and keep prompting and keep parsing this int for the every time they give us a new answer, we're going to try to parse the integer out of it again and again and again. So we kind of also want, because we moved this condition up here, it means like, where am I going to put this at now? Because actually, you know what? That's wrong. This statement is wrong. While it's not true is really what I want. Did anybody catch that? No, nobody said anything in the chat. Yeah, so this is, if that's not obvious, this would be bad because it would say, while my answer is the right answer, just keep looping while I got it right. And then basically if I get it wrong, it ends. And that's not what I want. I want this to be, I didn't see it either when I wrote it. I was just like, yeah, I'll just move this up here. I probably should have just ran it and then let us work through that. But I'm trying to keep on time here. So yeah, if you didn't notice it, this is a catch before I even ran it. So I want to run this loop. I want to run this loop only while they guessed wrong. And then if they guess right, it won't run because I'm doing the opposite. I'm saying only run this code while they don't match. But the moment they do match, it will make this statement false. If you think about it, like if the answer is 7 and the user input is 7, I'm making the statement 7 is not, I'm saying 7 is not equal to 7. And JavaScript's gonna be like, that's not true. That's false. 7 is equal to 7. So I don't want to say that, right? Like that's the right answer. I want to say this. So that's me just deconstructing all these variables. But I want to say while it's not equal. And then, yeah, exactly. Yes, exactly. So this makes it so that my winning message, the only way they can get out of this game right now is if they win. So they have to guess until they get it right, which is kind of what I want, but maybe they give up. I don't know, but they have no way to give up right now. It's just going to keep going until they get it right. I'm going to say, you got it. This is our winning message now. So they are stuck in this block of code until they get it right. And now we need to move up the rest of our conditions actually. So I've commented out part, so this else is no longer valid because I commented out my condition up here. So I need to get rid of that. So I'm basically refactoring my code at this point. All I really want is this nested if statement. I only really need it now because this is kind of like a conditional, like an if statement inside of this parentheses. It's as if I'm asking the if question. So the only thing I need to handle now is my asking about the input. So I can say, Here, let me leave these at the top just so you can see the undesired effect that we would get if I left those at the top. But we can see that, all right, while I've entered a bad input, basically, it's going to run through these conditions, right? It's going to keep iterating over these until I get it right. So every single time I get it wrong, it's going to do these comparisons. It's going to say, oops, you guessed too high. Oops, you guessed too low. And then this, like down here, like under everything else, the very bottom of this loop. So this is the starting block right here. I wish I could highlight this screen better, but this whole entire block is the while loop, right? So think of like this ending line right here, this outer, like right here where this closing brace is at is the last line. When we hit this last line, the loop comes back to the top, and it's gonna reevaluate this line again. Every time it reaches the bottom and comes back to the top, it's gonna rerun this again and ask the question again. It's gonna like, have you changed? Like, do you have a new value yet? Basically, are these two things still not equal? Because if it's still wrong, then we're going to just execute the code again. But if it is not wrong, aka if it's right, if they match, then we can finally that will get us out of the loop. It will exit the loop for us. It will go back up and reevaluate, and it'll say, hey, you got it right. Now we don't have to run the loop again. And it will get us out, which means technically we can just put a console.log at the end, because they can't escape this block until they get it right. So that's the logic behind this thinking right here. But I did this on purpose because I want you to see what happens. Positioning items in your loop is kind of important. So it's asking, it says, welcome to the game, guess your number. I'm going to give it 9. And then it asked me to guess my number again. I'm like, okay, I said 9. And now it says, oops, you guessed too high, try again. And I happen to know that I hard coded in 7. So I guessed 9. It said too high. I'm pretending as if I don't know what number it is. So I'm going to say, all right, I guessed too high. Let me guess lower. I'll guess 5. Now it says I guessed too low. So if I'm paying attention, 9 was too high, 5 is too low. It's somewhere in between there. So I could be like 6. Nope, it's still too low. 7. You got it. But I said 7, and it said, oops, you guessed too low. It said, oops, you guessed too low, and then it said you got it, and then it said thanks for playing. So I put in a 7, right? Yep, I put in a 7, and then it still ran this, and then it reached the bottom of the loop and came back up here and evaluated it. So position matters, right? So like I'm prompting at the top of my loop, and then it's immediately evaluating whatever I put and console.logging these. So maybe the top isn't the best place for these, right? Especially that first case that I did where it said, guess your number, guess your number. I don't want that to happen. It makes more sense to be like, I asked it the first time right here. It can run it the first time, and maybe I can just put it down here and let's run it that way. So it asked me to guess my number, 9. And again, it says too high. And I'll do the same sequence of numbers again, just to be consistent with what happened last time. So I said 5, and it said too low, and then 6, and it was too low, and then 7. Now it didn't say too low, and it says you got it. And the reason for that is because the first time I inputted a number, it was 9. So that was actually this prompt right here. I put in a 9, and then the while loop, it enters the while loop, right? So the answer is 7. I put in 9, and it said 7 is, I'm making a statement, 7 is not equal to 9. that is true. So it's like, that's a true statement. Let's run this block of code. And so my 9 goes right here. Is 9 greater than 7? Yes. So it went ahead and like outputted those contents right there. So I console.logged out some feedback to the user. And then we skip the else because we're doing the true side of the if statement, right? We're doing this block. The else only runs if that was false. So then that puts us down here. So we basically skipped over else because the true side was, because the true side of the if statement is what ran. We skipped else. Now we're here. So we ask, then we, this second one where I entered 5, from now on, my input comes from here. We're never rerunning this one again. So I duplicated the lines, but you know, for this simple of a program, it's probably fine. I put my prompt at the bottom because I know that when the loop reaches the end, it rechecks the condition. It's the very first thing this while loop is going to do. So I reprompted at the very end of my loop so I could grab the new number and make sure that it was updated before it reran this again. So now the bottom of my loop gives me my updated number, which was 5. So now we put a 5 in there, right? So 5 greater than 7. And when it runs this, 5 is not greater than 7. So we're not going to run this. We run the else side. So the else side runs, and again, it just runs that one, and it puts us back here again. So we're just iterating. We're iterating from top to the bottom of the block of this loop each time. And we can't exit. Like I could sit here all day and just keep entering. This loop will never stop unless I give it the value that matches right here. Like I have to make that statement become false. But yeah, so I could sit here and just keep pushing 8 forever. I could just like, it'll just keep going forever. I could put, and then look, and I put nothing in there, or a C, or, so it's just, it doesn't even care what character it is, because remember, it's not a number. But if I do 7, I can get out of it. So far, it's a pretty simple program, and it works, but we're hard-coded. So this last one, we'll look up this last one in the docs. Anybody have any questions so far on anything?
If you were to write that like in a context of a function, how would that look like?
Which part?
Like that it's like if you were to do like the while, I don't know, if you were to write that in the context of a function, that whole program, change it so it would be like the while loop would be like in a function or something, a JavaScript function. How would that look like?
Yeah, so I can take this whole block of code right here. Let's I'll put a note. My while loop was here, and we'll come back to that in a minute. So I'll come somewhere up to the top, maybe up here at the top, and we'll create a function. And first, what would you call this loop? Like, I mean, I don't want to just call it loop or anything, but what was it doing? It was basically our game loop, I guess. We could call it that. I don't know about arguments at the moment, but let's just roll with that for a second and see what happens. I'm just getting the tab indentation correct here. So I have a function. It takes no parameters at the moment, and then my while loop the indentation looks all right, and the braces. So I have a function now. So now where I had my code, I could call in place of it game loop. So this is like invoke or call your named function. I don't have to pass it anything right here, but I could. But I haven't made sure this runs yet, right? So there, I could have broken references because I moved the code up higher and I put it in a function, and like this function doesn't know, well, this comes back to scope, remember? We talked about scope. So functions can see outside of their scope. So I can already tell that answer will be fine because functions can look out and see answer, but user input is not defined in here. Like it's not anywhere above this point. It's technically down here. So we could break our code potentially if, yeah, let's find out. I'm thinking of two different scenarios right now, so that could potentially happen. But my thought is like, uh-oh, I might have broken my user input. So welcome. Okay, that's a weird order too. Guess your number first now. Guess your, well, let me clear my screen actually. Sometimes this console, it's probably good to like always clear it. Oh yeah, yeah, it was like a leftover message from the end of the last game. Just to be sure. Okay, yeah. All right. So welcome to the guess a game, guess your number, and I put like 7. You got it. Cool. So too high. So it's still working, and I wonder if that is because, what if I called this function? Let me comment that out. So this was my second thought, is like, even though I don't have a user reference or user input reference. Oh, you know what? Let's do that. I think I know what happened. Yeah, what am I? So I want to see this come out. I'm going to put my code back. Oh, I'm going to put this code back real quick because I think something else might have happened right there. Guess my number is 7. Oops, that's not what I want to do. That's the right answer. I misspoke. Go me. I thought I tab completed that. All right, so 8. What am I? 8. So it knows that it's 8 because that's interesting. What? Because I called it later. Let me do this. If I call it here, it definitely shouldn't exist at this point. Yeah. So it looks like because user input is defined out of all of the scope, like this let user input is defined at, it's not inside of a function where I'm defining it. So it's technically at JavaScript's global scope. So the function can see that still, because the function, higher order functions, right? They get, the definition of the function gets brought to the top, just like these global variables do too. So my function can see it even though it's, I should put it this way. The function can see it, but as long as I call it after the fact, as long as I call it below here, right? Because if I call it before, I've defined and called the function as far as JavaScript's concerned before it ever set it, which is interesting. Yep. Awesome. So that if we wanted to, like, we could wrap this part, we could make this whole thing part of the function, which would make more sense than splitting out, or we could make user input be it'd be more appropriate maybe to like call our game loop passing in like our initial input. Maybe, I guess we could do that. But now I have to call this, now I just have to change this initial input, the references here, so that they line up. So now my initial input goes in, but I have to update my function to accept that. So I could call it user input right here. So then we're basically setting the first value. We're sending that one in as the user input, which then just keeps getting overwritten anyway. Let's just make sure that works. 8. Aha. User input is not defined. And that says on line 50, line 50. Oh, because I didn't update that one. So I forgot to update a reference. So I have to pass the original input back in. This is what happens when you change variable names on yourself. You have to make sure you go update every spot it was referenced in. So 8. All right, so now we're back to it working. 4, 3, 2, 7. So yeah, it works again. So now, but do you see, all I did was I took that whole chunk of that block of code, right? And I said, all of this is going to live in a callable function, right? So if I wanted to actually play a game, I could make them play more than one game, right? Like this could be the first game. I could put them into like 3 separate games. So it's starting to become a little more reusable. If I want to start a game, all I have to do is call game loop and give it the first value that they said. So I wouldn't do this here. I would probably, this is how you start refactoring your code. You come up with an idea like that, right? I want to put this in a function and I want to call that function so I can play one iteration of a game. And then every time I want to play a game, I'll call that function. But then that makes your code start to look like this, where I have to say, I have to initially prompt, so I don't have to do this here. The first one I don't have to do it for. Oops, I don't know how I did that with that was a short key. But the second time, I have to make sure I reprompt again right here if I want to do that. Like if I want to end a game and then start a new game again, I basically have to, let's look at that. So guess a number. 8, too high. I know what it is. It's 7. This is going to end the game. But it threw me. It actually didn't. My got it message, like you got it, is now at the very end of my program, which is it needs to go somewhere else basically. So I could say 8 again and it says too high, and then I say 7, or I say 4 again, and then I say 7, and then this is the 3rd time I called it, right? Like I called the game loop 3 times, and every time I press 7, I won, and it technically ended the game, but my console.log was really late. It was at the bottom. It was after all 3 calls. So technically this should go as part of my game loop outside of the loop. Like when the loop ends, you got it, thanks for playing. So this is just like replaying the game to refactor my code at this point. So if I say 8, it says too high. 7, now it says thanks for playing. Now I kind of know that it like ended, but it automatically threw me into the next call, like the game just started again. If that makes sense. So like this game loop, every time you call it, now that it's a function, we can keep calling it and reusing it over and over again. And I can send in the initial input because I have to, because the very first line of my loop needs to have that input. If I want to if I just want to pass this function around to other files or something, where maybe this global variable isn't set in there. Maybe it was maybe this happened inside of another different function, so they didn't have a global. because it will work because of this global, it will work with that without that parameter. But I technically, if we said like, if we wrap these in two separate methods, right? Like intro message and it intro message, or maybe start, wait, what did I call this again? Game loop. Maybe we'll call this, yeah, I'll just call it start game. It doesn't really matter. It's kind of like starting the initial game. So I just want you to see that this will break if we take it out of the context of the global scope, the variable. So we're going to put all of the logic in there, and even this logic, we're basically going to pull everything that's at the global level and put it inside of here, because this basically handles our gameplay. Well, it handles the starting of the game. But now if we run this right now, nothing happens, because all we did at this point was define functions. We never called, like this function right here calls the other function, but we never called this function so that it could call the other function. So I technically need to have one line in here at the bottom, you know, start game. It takes no parameters. So start game is going to kick off the first function call. So it will run these three different game loops that happen, right? So now it kicks it off, because this is our first call. This is our call stack. JavaScript came in and JavaScript came in here and it ran from top to bottom, and it pulled all of the function names to the top, because that's the, if you want to go through the higher, what was it, session 6, I think, higher order functions, where it basically pulls all the function names to the top so you can reference them later in code anywhere. The only line that it doesn't run these when it comes, reads it through top and bottom, it's not running the function. It doesn't execute the function, but it does grab the reference to the name of the function. It says, all right, what is this function's name? I need to store that function so we can run it when I call it. And that's what this line is this is you saying, all right, I'm ready for you to run that logic now. Like this line 66 is like, I'm ready for you to run that code. So this kicks off the code, the start of the program. And then all the rest of these are just, this is our other function call. So this function has a nested call to another function. And when we are talking about recursion, right, where that function called itself over and over. So this isn't recursion, but you could sidetrack if you make too many function calls. If I had start game call itself from start game, this would become recursion. So start game was called here. We kicked off the code. It's going to come in here to read this from top to bottom now. Once we get out of the third game loop, start game is going to call itself again. We will never have exited out of the very first call to the start game, if that makes sense. Like we can't get out of this function now, because it will just keep calling. Every time we end a game and we get the right answer, it recalls. So this is this goes back into recursion. So don't do this to keep your program going, because it will eventually you'll run out of memory and it will fail. Don't use recursion as like an infinite loop, because it's not a good idea. Don't use as infinite loop, infinite program loop, I guess. Yeah, don't do that. You'll have to play it like thousands of times to get it to fail, but you'll eventually run out of memory and the program will crash. But this is not recursion right here. This is us just calling that logic one time. And if you think about it, like prompt, this is a function call. Parse int, it's a function call. Game loop is a custom function we just made, but it's a function call. So your function that you define can call other functions. And you can have, like, you can create your own set of logic and steps to follow to do that. Do you want me to leave it like it is, or do you want me to put it back the way it was so you can try to do it?
Can you put, thanks for showing us that. Can you put both of those scenarios in Slack as a reference?
Yeah, I'll have to paste this version first and then like undo my way back out to the other one. Or maybe I can I'll put them both in there. I'll try not to modify this one too much more, but yeah, I'll put them both. Extracting our logic out to a function for context. Just in case somebody who's not in here is going through going, what was Chris doing? I was showing him how to do some stuff. All right. I'm gonna leave the to do for checking for invalid characters, because it's not, there are methods on a string and we could probably look them up. I won't give too much away here, but string methods, JavaScript, because a prompt always returns a string, there might be something in here that lets us check. Actually, because you don't know all of the methods yet, it's really hard for you to like just guess what it would be. So you could say JavaScript check if string is a number, like that. This would be a good way to like Google search to try to figure out what a method name might be. Check whether a variable is a number or a string in JavaScript. So that's a interesting way to go about it. This is if you see stuff like this, it's a regular expression. That's a different topic that you would learn. You would learn something like that in the cohort, the curriculum program. There has to be this one. Okay, so this one says built-in way JavaScript check string is a valid number. So is nan, it returns true if the variable does not contain a valid number. So if I pass it is nan 1 2 3, gives me a false. If I pass it a string version of 2 3 and 4, it gives me a false. I guess this is a representation of infinity. If I pass a string in that has characters in it, it says true. So if you think about it, all these inputs, this one's false, this one's false. I mean, I guess it doesn't really give. Maybe there's a way we can combine that though. So the way I'm thinking about it is just from looking at this, like how can I use this so that I can perform a check in my code? And whoops, I need to get out of that. Oh no, I have to play it 3 times. So is nan, first let's make sure it exists, and it exists, right? So my input coming out of, where'd it go? When this prompt, so I'm trying to check for valid, like a valid number. So if they entered like Chris, I'm asking the question, is this value that I'm giving you, is it not a number? Which sounds kind of weird to say. Is this value not a number? And it says true, Chris is not a number. But if I pass it 1 2 3, it says false. So 1 2 3, is it not a number? And it says false because it is actually a number. So it gives us a false. It's giving us, the opposite of that. So we might be able to use this to like check if their input was valid to even use, so that we don't have them enter like a value like that, or even just like 7A, which would have no meaning, or A7, right? Like they accidentally hit a key on their way, like a slash or something. So if they did like 7/ because they did unexpected token. Oh, I wonder. Yeah, sorry. That's like the slash. Maybe I should use that slash. If you ever put that just in a string, it would, I think JavaScript would convert it to that for you. Let's find out. What happens with that. Nope, it's a syntax error. That's because of the special characters like these. They have special meanings. So slash is what they call an escape character. I didn't mean to like accidentally talk about this, but it's an escape character. But when you combine it with certain characters like n, this is a new line break. I showed this before. First line slash, well, if I do this, it puts it all on one line. How do you get output to print to 2 lines? You put a slash in the special character in there. So you get first line and then a new line, slash n is new line. And if I put a slash t, these are just a couple of them, there's a lot more. If I put a slash t, it puts a tab, invisible tabs, like as if you hit tab in like Microsoft Word. It's like a tab character. It's considered white space characters. So slash n is a white space character. It takes you to a new line. Slash t is a tab character. It looks like it pushes you out like a couple spaces. It's not one space, but it looks like a couple. It's called a tab character because it's its own type of a character, but it's not like a regular space. Because if I put a tab right there, you'll see that this is a space right here, this smaller one, and that's a much bigger space. It looks like a couple of them because it's its own character type. Anyway, I didn't mean to talk about that. These are just things you learn as you're going along, but yeah, we probably can use is nan and pass in our string value like that, because that is the same for 1, 2, 3. So if we get false, it's valid, which seems kind of weird to say, but if it is true, we're saying the argument given is not a number. So you can use that to do a conditional check. Like I could write if is nan, if it's true, right? If that argument, initial input, if that happened, it's like, hey, this actually isn't where you want to put it. I'm just kind of like mocking up real quick. You're going to have to find the right spot for this, but hey, that wasn't a valid answer or something like that, right? Like this is how you could like combine what I just looked up into your code after you make sure, like test your thoughts on it. This is the whole process of just basically like assembling a program and like trying to think your way through it and everything. So I'm not going to leave that one in there. There might be other methods that you can use. There's so many different solutions that you could come up with for determining if they entered the wrong thing or not. And we could spend a bunch of time just going through like, not that one, but if I went back, you could just number is integer. That seems interesting. We could use, yeah, so you can see, you could probably use, it looks like it's a static method. So you could just literally say what they said right there. Let me put that back real quick. So instead of that, an alternative solution maybe, what was it? Is integer like that. And we could put initial input in there. And this one is asking if it is an integer. So if they did put an actual number, let's try it in the console real quick. And then I'm going to end on this note. It is integer like that. And if I put 1, 2, 3, it says true. What happens if I put a string of 1, 2, 3? It says false. So that might not be what we want, right? Because we know that prompt gives us back a string, but we know that if we parse, if I do a prompt, right, and it gives me back 1, 2, 3, like that. If I parse int on that, so maybe I can combine these in a sequence to get what my desired effect. So if I parse int, it would give me that, and I can combine that with is integer like this. So it says that's true. So I can combine parse int with that. What happens? There was that one other case, right, where I did a parse int on something that's not not a number, right? And we got not a number. What happens to that if I do not a number? So false. So that might actually, that line that's right here might work for our case if I did that combination where I said, is it an integer, but also parse int? But I technically, I already did this line, right? I did this line right here. So I don't have to do it again. I already did it once. So technically this is either gonna go in as a number, or if it's not a number, it's gonna go in as not a number. And that's still fine as long as it's passed into this method, the static method call. Whoops. And that's, this is gonna, in place of this call, it's gonna put a true or it's gonna put a false. And based off of that, if it's true, it will run this. But if it's false, it will not. So you gotta think about your logic there. If it is a number, we actually need it to be in the else now. So you have to think about your conditions. Anyways, I think I'm gonna end on that note. And I don't want to leave a bunch of answers in here, because the whole thing about this is to try to do things yourself. So I'm gonna get rid of these duplicates and leave the original. Initial input. And let's just run it real quick. 8, 5, 7. And it works, yay. We have a program. Can we use number? You might be able to just, you can always hop in a rep, like I do this so much, hop in a REPL and see what 1, 2, 3, whoops, I typed that wrong. Hop in a REPL and just see what this gives you. Like testing expectations, like number gives me not a number. So yeah, you could instead of parse int, you might be able to do, what if I just give it a number and it's already a number? It gives me back the number. So yeah, you could totally, instead of parse int, it looks like you might actually be able to do number like that, because it would give you not a number again. So for your condition, you're actually gonna have to figure out what spot you need to put this in, right? Like you have to figure out where does that if statement need to go that does number is integer if you use that one, or if you use is nan instead, is not a number. Yeah, so anyways, it's all about just trying to problem solve step by step. And I'll share this code with y'all so you can take it and add more features to it or tweak the messages and mess around with the loop. See what happens if we do this. If I flip this operator around and run it and I give it what happens if I give it the wrong number now, like a 4? Thanks for playing, you got it. No, I didn't. Or if I run it and I get it right. Now, if I know it's 7, right? But it's telling me it's too low now because it doesn't know what to do. It's just falling in the else category because because my loop is written wrong. Basically, it's saying when it's right, run this code. I want it when it's wrong, run this code. Anyway, I said I was going to show you random. Let me see how difficult it is to just reference JavaScript, generate a random number. So right away, I can see some of the top results. I already 2 of them. So this one looks like it's promising. Math.random, a number from 0 to less than 1. Get random int. All right. So again, the REPL, we can just test it real quick. Gives me a decimal. I don't want a decimal. I want like a full number. I don't want people trying to guess like this specific of a number. That's way too much. So that's probably why they have this. So actually, this is the type of, I want this. Like I want a random integer, like a full whole number. I can actually, this works right here. Like it's using math.random and they're doing some cleverness so they can get a full, this isn't built in. So I'm gonna have to copy this whole thing and say, I'm pretty sure I need that so I can use it. Now I can call, this is a function. All I have to do is pass it the maximum number I want to go up to, right? Whoops, actually, I have a habit of doing, well, let me do this. I have a habit of doing these kind of in order. I'm going to put the answer inside the start game where I think it should go. So welcome to the guessing game. It's going to pick a number here. So I'm going to call that function that I just brought over, get random int. And now I can say get random int, and I pass it the maximum value I want it to grab a number up to. So I can say like 10. But I'm going to do this ahead of time just so we know what the answer is, because otherwise I'm going to have to sit here and guess the whole time and actually figure it out, which is fine to do later when you're ready. But did I fix my loop? I did. Is it just taking a second? It won't stop. There it goes. Okay, so I put the answer so I could see it. I know it's 6 because it's randomly generated, right? So I'm going to guess everything that's not 6 for a second. So 1. Oh, I broke something already. Answer is not defined. Oh, I got myself right there. Now it's trying to reference an, I'm calling game loop before answer was ever defined because I put it in the scope of a function, so it doesn't exist now. So now I have to do one of 2 things. I either have to pass the answer for the game into the function, or I need to go put it back where it was at, which I'll let you figure out how to pass it as a second argument if you want to do that. But let me just move it up. I'll just move it up to the top of the scope, that outside scope like that, and we'll run it. Actually, we'll stop and then we'll run it. Okay. Let me try that again. So 1 says I'm too low. 5 says I'm too low. My answer, it randomly picked, it's different this time, right? It's 9. And if I hit 9, I got it. And if I play again, now it's 0. So 0 isn't a normal number to guess through. So maybe there's a way to change that function so it does, where'd it go? Math random from, it does from 0 to 1, and then they times it by the floor. So there might be a way to edit this so that it starts from 1, or actually we can probably say, I wonder if I just, off the top of my head real quick, what if I, math.random returns from 0 to 1, what if I just add a 1 to that? I don't know. Let's see what happens. It gave me a 10. Well, I guess I'll just put a 10 in. Okay, so now that doesn't give me what I want. Now it's just giving me 10. So that breaks it. Math floor max. So I wonder if there's a way I could, oh, because it was probably doing multiplication first. Let's try that. 11. That's 1 more than I want, but let's see if it will work. Nope. So I can't just do that, right? So maybe I could conditionally check for a 0 before this returns. There's probably a way I could do it, or maybe I could just go. I'm not going to try to solve this right now because we're way over on time. So I'm not going to try to solve their function, but we could probably look up like JavaScript, generate a random number between. If I said that maybe, then generating random numbers in a specific range. That seems more like what I want, minimum and a maximum. So you can see what they did here. They did the multiplication of it. I was trying to do something hacky like this where I just like threw in a minimum. So I could just take this function and try this. It's probably good to take a moment to try to understand what they're doing to try to figure that out. But now I can just call that one instead here. And now I can give it 1 to 10 because it takes a min and a max. Sorry, I'm just trying to fix this real quick. I hate that it does that every time. Oh, not a number. What happened? Why did I get an answer of not a number? 1 and 10 and plus min. That's interesting. And then it gives me a decimal. So that's still not what I want. So yeah, so if I wouldn't know off the top of my head, maybe I should have read the comments. This is random number between random integer. So when they say integer, it's a whole number. So maybe I should have used this one instead. Again, we could just change it real quick. It still takes a min and a max for parameters, and I'm passing a min and a max. So now I got a 4, which is good. Let's put 4 and run it again. I should get a different number. It should be randomness each time. So there is a chance I can run the same number twice, but it shouldn't be that often. So, and our range is 1 through 10. So you could keep running it over and over and just make sure that you're staying between that range. And then you'll know, like, hey, I know my program stays between these ranges, so they should never have to guess outside of the range. But yeah, it took a minute to find that, but it's fine. It happens. I think there was just one missing calculation to get rid of the decimal, probably math.floor. All right, I'm gonna stop there. I'll share this code in Slack. I'll try to undo a bunch of what I did. I'll copy what I have and then undo what I did to get back to the old version before we put it into a function, and then share both of those. Yeah, but y'all have a good night. And then I'll save this video. I'll stop this recording and make sure it saves.